Hey, I'm Juan from JuanTutors.com. That's Whaley. Whaley says she loves my hat. I promise that that's relevant. And today we're doing the Algebra 1 regions from August 2023, the August 16th, 2023 regions. A lot of you actually took these regions. Some of you passed, some of you on a higher grade, and some of you didn't quite pass. So today we're going to go over every single problem, not only how to do every single problem, but also advice on every single problem on how to eliminate at least the multiple choice, how to eliminate at least one choice, and how to actually tease out points from problems that are in the part 2s, 3s, and 4s. So we will do everything that we can to get you the best grade possible. And listen, before anything, I promise you can pass this test. I believe in you. I have never met a student in my life that couldn't pass the Algebra 1 regions with a lot of really genuine, diligent, hard work. So I believe in you, and I know you could do it. The very first piece of advice, though, before even the first don't overthink, the very first piece of advice that I could give you is don't skip this part of the video. Don't skip this part of the video. This is the part of the video where I'm giving you the best advice that I can give you. The first thing, don't overthink on the problems. What does that mean? Overthink. I mean, you got to think. How could you overthink? Well, what if you say in a problem? What if you're thinking about the problem and you come to a good conclusion, but then you say to yourself, "But what if this thing that I know is true maybe isn't true?" But if you know it's true, it's true. Don't let yourself believe that a totally implausible thing might be true, right? What if you know that there's a multiplication and you have to do a division, but then you say, "But what if it's just a subtraction?" You do the subtraction instead. That's overthinking. If you know what you're supposed to do the thing that's written. Don't refuse to do algebra on paper like so many of you guys do. I'm sorry. So, look, I love you guys, and I've been a teacher for 15 years. I've been a tutor for 25 years, and people pay me a lot of money to tell them basic things like stop skipping steps. So, don't refuse to do the things that you know how to do. When you're solving an equation, write down the equation and solve it. Don't skip the steps, or don't think that just because it's faster in your head that you should do it in your head, because first off, no, you're losing accuracy. Second, no, it's not faster to do it in your head. No, it's not faster to not write it down. It is strictly faster to write it down. uh Again, don't refuse to do all steps on paper. All steps should be done on paper. They shouldn't be done in your head. The second point is don't underthink. Don't ask yourself a question but then assume the answer. If you ask yourself a question about the math problem, answer the question to yourself about the math problem. That's an example of underthinking, just assuming a certain answer. Don't. Answer your own questions to yourself. Use all the information from a problem. I will tell you this. I won't say that no problem contains irrelevant information. Um, but I will also say this. If you find three numerical or algebraic pieces of information on this test that is actually not relevant to the problem, three, post the three places, and the first person who does that, I'll give 3 hours of free tutoring right now. I will say that, and I charge a lot of money. 3 hours of free tutoring. I'm so sure that, and by the way, there is a little giveaway somewhere in this video, but I'm so sure that this isn't it, because I'm so sure that there aren't three irrelevant pieces of algebraic or numeric information on this test. Everything is relevant. There might not even be one. Honestly, I don't recall right now. I don't recall one, but I did do the whole test before this, but I don't even recall one. So assume that all information is relevant, and if you haven't used a piece of information, you have to go back to get it. And use all algebra with steps. Again, that's part of the don't overthink and don't underthink. The next part, know what you know. When you know something has to get multiplied, don't say, "But what if it's not?" Like if you have to multiply, multiply. If you have to divide, divide. No, though, like x minus 3 means 3 is being subtracted from x. Negative 3 times x, the number negative 3 is being multiplied by x. So the operation is what tells you what to undo, right? X minus 3, undo minus 3 by doing plus 3 on both sides of an equation. Negative 3 times x, that's a multiplication. You have to divide by negative 3 to undo a multiplication by negative 3. So know when what operations are what. Opposite of plus is minus, opposite of times is divide, the opposite of the squaring operation is the square root operation. Know your order of operations. And if you know the formula, write it down first and then use the formula. Okay? The second piece, know what you don't know. Don't trick yourself into doing something illegal. The example of like negative 3x, negative 3 times x, but you say, well, that's a multiplication, but what if it's not? What if it's an addition? And then you add instead? You know that it's not an addition. You know that it wasn't a subtraction, so don't go and add. Also, uh, the taking the like eliminating a squaring operation by dividing by 2 is illegal because the squaring operation is not multiplication by 2. So do the inverse operation whenever you can. The next, don't guess at what is true. Instead, verify it. Because a lot of students do this, that they guess at something being a certain value being whatever it is, and then they use that. Or they say, I think that the um, the problem says that she buys 5 of something when the problem in fact says she buys like 3, or that or they read the problem just once and then they try to remember, like it's like the price of apples and the price of bananas, and they try to remember which one was the price of the apples and which one was the price of the bananas instead of just going up and reading it. Go up and read it again. It's actually normal to read a problem up to 5 times. Actually, 5 times on average is what I meant to say. Students read problems up 5 times on average. So if you haven't read if you read the problem once, you haven't read it enough times. Um, if you read it twice and you still don't know how to do it, you haven't read it enough times. You have to read the problem 5 times before you could say you don't actually know how to do it. Okay, it is normal, and you have enough time to do that. Um, and if you read it 5 times and things are starting to come to you, maybe the sixth or seventh time. Now, if you're reading it 10 times, that's maybe when you need to think about another strategy, like the other strategies that I teach you. Don't assume anything when you can verify it. And finally, this is the best piece of advice, labeled and highlighted. If you don't know how to get the answer, use correct math to eliminate wrong answers. I know that sometimes we don't know how to do a problem, which I mean, it happens. I mean, I come across every once in a while. I come across a problem that takes me like a minute to really remember how to do it. So if I, as a rule, multiply my skill or lack thereof in any situation by 5, so if it takes me a minute to think about how to do it, multiply that by 5. It might take you 5 minutes to figure out how to do it. And sometimes, if you're running out of time, that may be an insurmountable amount of time. 5 minutes to stare at nothing, maybe. But here's the point: if you don't know how to get the answer, but you know how to do something with the problem that will eliminate some of the answers with correct math, you should do that. One great example in geometry is using size comparisons. One example in algebra, plugging in values when you know how to plug those in. And I will give you examples on every single problem on how to eliminate at least one choice. Okay? At least one choice every single time. Now, I can verify that in every single multiple choice question here, it is possible to eliminate every incorrect answer using true correct math. I will not do that for every problem, but for every problem, I will eliminate at least one choice using correct math to show you that there's value there. One thing is, as you may know, the multiple choice, you only need about a little over a half, maybe 13 multiple choice questions to pass this Regents. Um, Correct, and then you've passed. Now that doesn't mean that you should focus only on the multiple choice. It really doesn't, and I'm going to explain a few times why during the test. So I'm not going to explain it now. But that said, um, on 24 multiple choice question, if you wild guess on all 24 questions, on average you're going to get 6 right. But if you eliminate at least one choice on every single question, now you get a third of them correct. A third of them of 24 is 8. That's 2 more multiple choice questions. So now if you start thinking, well, think about the questions you just know how to do. Those are just plain right. Think about the questions you don't know how to do, but you happen to be able to eliminate all 3 incorrect multiple choice questions. Those become questions that you have to guess on, but guess out of one choice, the only correct choice. That boosts your grade so much. Eliminating choices boosts your grade so much. Okay? So that's the short advice that I'm going to give right now. I'm going to tell you later on why you should not focus just on the multiple choice questions. I know a lot of teachers say focus only on the multiple choice questions. It's actually, unfortunately, it's not complete enough as advice. Love you teachers if you're watching with your students, but do understand, I it's just not complete enough as advice. Um, the the problem with that is that there are so many points to be gotten in the um part twos, threes, and fours, that just like it's possible to pass the test by only getting multiple choices right, it's actually also possible to pass the test by just getting the part twos, threes, and fours and never doing a single multiple choice. But of course, why would you ever do that? Not do the multiple choice? Well, then I would argue, why would you ever not do the part twos, threes, and fours? And this is the crux of it. And this is the piece that I'm hoping convinces you in the end. And I haven't read this slide yet, but I'm hoping this is what convinces you. For those of you who have graded recently the Algebra 1 regions, this is, let me see if I could just show you what my test looks like when I'm working on it. Let me see. Will it focus? It doesn't have to be focused, but the point is, you see that there's a ton of writing there. There's a ton of writing there. When I'm grading these tests, what they do is they put the answer sheet somewhere in the booklet and they hand it to you. So I actually see, not on purpose, but I actually look at what the multiple choice booklet looks like. Students who don't do the part twos, threes, and fours don't do the part twos, threes, and fours because they have to show work. But you have to be able to do the part ones, the multiple choices, you have to show work. You have to be able to do the work, at least a little bit. But I'm telling you this, more than 50% of students don't do any work at all in the multiple choices. They're literally just guessing. So if your student is being told to only focus on the part ones, they're probably not doing any algebra at all. And you, as the student, if you are only focusing on the part twos and not doing any work, you're probably not going to pass. You need to do as much work on the paper as possible, as long as you know how to do it. That's why for every problem, even if any strategy that I teach you gets you the right answer without showing work, right after that, I'm going to show you how to do it with work. And I need you to write down everything I do. And that's one of the bullet points here. So now, what to do. This is how to use this video. How to use this video. If instructed by the teacher, do what the teacher says is the first bullet point. The second bullet point, do what the teacher says. Don't try to simplify what the teacher says. She says to do all the work, do all the work. Just do it. Look, they have your best interests at heart. Why are you fighting that? I know that, not that you are fighting that, a lot of you just aren't, but I know that a lot of students do fight it. Students that I teach, students that I tutor, they fight that advice. So do what the teacher says. Now, if you're 2 or more days from the Regents is not tomorrow, do every single problem before I do it. You could listen to me read the problem, but do the problem before I do it. If you don't know how, you have to, this is how to use this video, you have to give an answer anyway. I don't care what I do care what strategies you use. You want, as you're watching this video, your strategies should actually be improving. So use the strategies that I'm teaching you. You have to give an answer. If you know how to get the answer, get the answer. If you know how to eliminate some choices, eliminate some choices. No matter what though, if you haven't circled an answer, you can't watch me do it. Now, you also can't say, I'm stretching my arms here. You also can't say, oh, I think the answer is 2. And then watch my video. I think the answer is 2. No, you have to actually choose it. This is why I've watched so many students in person say, I think the answer is 2. And then I do the problem. They're like, the answer is 1. I knew the answer was 1. I should have picked that one. Or I think the answer is 2. And then the answer ends up being 2. And it's like, oh, I got it right. Both of those things happen. And one time, and only one time in my life, I was actually did this to the student. Like, I think the answer is 1, but I'm gonna pick 2. And they're like, the answer is 2. And they're like, I knew it. And I'm like, no, the answer is 1. Like, oh, I knew I should have picked 1. No, the answer is 2. And I actually joshed them a little bit because they really weren't getting the point, that they were not really selecting a problem when they said, I think the answer is 2. Do not say, I think the answer is 2. and then watch my video. Or I think the answer is 3. No, you have to actually select it. My answer is 3. My answer is 1. And then you can watch me. Okay? So if you don't know how to give an answer, how to do the problem, you have to give an answer anyway. But you have to do that with correct math. As much correct math as possible, as much strategy as possible. If there's anything that you left on the table that you didn't do yet, you have to do it before you watch me do it. Then you watch me and write down what I do. Okay? Then, remember, this is 2+ days from the Regents. Track the problems that you got wrong and redo them after this video. The point is that after you've finished watching doing the whole Regents and watching this whole video and doing all the problems, go back and actually redo every single problem that you lost even a single point on. And then rewatch me until you've gotten every single problem right. That seems like a strategy to maybe get you a few points learned on the Regents. Students who do this sometimes go from like a 50 on the Regents to a 90, which means they did focus on the part 2s, 3s, and 4s too. From a 50 to a 90 in like 2 days. And a 90 is enough to get you into some really good classes later on in high school, later on in college. And it's a deserved 90. It's not even a fake 90. This advice is not even test prep advice. This is an earned 90 in a way that will actually last a longer time. If the Regents is tomorrow, do the problem before I do it. Again, just like before, you do have to do the problem before I do it. Then you give an answer before watching me do it. You have to get to a final answer, just like I talked about. Don't trick yourself into saying, oh, I think the answer is 2. That convinces you that you think you chose 2. Because then if you think the answer is 2, but you have a feeling that it might be 1, you'll end up convincing yourself that you got it right and that you didn't. You have to actually make the selection. Just like in the Regents, you have to make a selection. Then you watch me and write down everything I write down. And you do that for the whole video. And if you still have time, see the above, the 2+ days instructions, because then if you still have time, you have some of the time to do what I say. So repeat means repeat the video with only the incorrect problems. So that's what I mean. So if you've already, if the Regents is tomorrow, but you've already finished the whole video, then you go back and you redo the problems, only the ones that you got incorrect, redo those, and then see if you got them right. That's the best advice that I could give you. The Regents that we're doing is the Algebra 1 Regents. You don't have to read this front page, except at least one point in the time that you're working. So we're gonna actually explore this video, the Regents a little bit, so that you don't have to do this for the first time while you're taking the test. All right. So first, we're gonna read through the beginning. If you've read it already, great. But there's some important pieces of information, and I may actually edit what's said a little bit. So do pay attention. First off, obviously you're not allowed a calculator. I'm sorry, you're not allowed a phone, but you're allowed to have a calculator. The possession or use of any communication device is strictly prohibited when taking this examination. If you have or use any communication device, no matter how briefly, your examination will be invalidated and no score will be calculated for you. This one, print your name and the name of your school in the lines above. You have to do this. You don't know how many times students didn't get a grade because they didn't print their name and the school's name. A separate answer sheet for part 1 has been provided to you. Follow the instructions from the proctor for completing the student information on your answer sheet. This one. This examination has 4 parts with a total of 37 questions. You must answer all questions in this examination. Record your answers to the part 1 multiple choice questions on a separate answer sheet. Don't skip multiple choice, obviously. Write your answer to the questions in part 2s, 3s, and 4s directly in the booklet. If you skip steps on the part 2s, 3s, and 4s, you could easily lose points when you don't have to. All work should be written in pen, except for graphs and drawings, which should be done in pencil. Clearly indicate the necessary steps, including appropriate formula substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. This is the part that I'm going to contradict real quick. Note that diagrams are not necessarily drawn to scale. I'm not going to contradict it in the sense that diagrams don't actually have to be drawn to scale. They don't have to be drawn to the correct sizing. The reason I contradict this is that I would bet money that Algebra 1 Geometry and Algebra 2 Regents combined, all 3, that 1, 2, 3 tests for this Regents week coming up, that there won't be 3 shapes that are not drawn to scale. So yes, it's true that diagrams need not be drawn to scale. I'm not saying to assume that it is drawn to scale, but I'm also just strictly saying don't assume that it's not drawn to scale. That's the problem. That students, if it says need not be drawn to scale, students assume that they're just strictly not drawn to scale. Don't assume that they're strictly not drawn to scale. In fact, it's actually really good advice to check whether it's drawn to scale. Now, if you have no clue how to do the problem, in fact, it's super duper duper good advice to assume that it is drawn to scale. It actually is good advice to assume that it's drawn to scale if you don't know how to do the problem. It often, really, really often gets you the right answer. Okay, so that's why that piece of information is important. Okay, where's the drawn to scale? Okay, the formulas that you may need to answer in some of the questions in the examination booklet are found at the end of the examination. The sheet is perforated, so you may remove it from the booklet. We will explore that at the right after we read this. Okay, and you do want to explore that formula sheet. A lot of your formulas are there. Just get the formula from there. Scrap paper is not permitted for any part of the examination. You do have to show all work on the test. But you may use the blank spaces in this booklet as scrap paper, and I'll show you that they give you a lot of space. A perforated sheet of scrap paper is provided at the end of this booklet for any questions to which the graphing may be helpful but is not required. You may remove the sheet from the booklet. Any work done in this sheet of scrap paper will not be scored. You can use the graph paper. A lot of students don't. It's not going to be scored, but it actually is useful sometimes if you want to just draw a diagram to scale for yourself. When you have completed the examination, you must sign the statement printed at the end of the answer sheet indicating that you had no unlawful knowledge of the questions or answers prior to the examination, and that you have neither given nor received assistance in answering any of the questions during the examination. Your answer sheet cannot be accepted if you fail to sign this declaration. Notice a graphing calculator and a straight edge or ruler must be available to you while taking this examination. So graphing calculator includes the TI calculator. Okay, I'm gonna have you download a calculator emulator if you don't have one. The Calc 84 emulator is a phenomenal emulator. If you have it, and it's on every phone. Calc 84. Okay, Calc 84 is an app available on every phone, and that was Wabbit Emu. You just saw on mine. The Calc 84 app is just available on every phone. Wabbit Emu is becoming less and less available. Okay. Okay, so I'm gonna read the instructions on the part ones later, but you see a diagram here, some diagrams here, a diagram here. You see a bunch of blank space, you could use it. I'm gonna give advice on how to read tables. A lot of blank space to show work, show your work, okay? Here's the part twos. We'll read that when we get to it so that you don't necessarily have to read it yourself. Lots of advice here on how to get points. And one of the reasons why I tell you don't skip the part twos, threes, and fours. Here's a table here. And I do sometimes leaf through this. I see a quadratic, I see a sequence there, some factoring, another solving. A part three, we have to read that. Lots of words. A lot of students get to this page, see a lot of words, and say, I don't know how to do it. In fact, this is actually just because of the way problems are created. The more words in the problem, often the easier the problem is. So it goes the other way around. Some graphing. Big advice on graphing. Don't get lazy on the graphing. I know that in class you might be lazy on the graphing and just make a sloppy graph. But in fact, graphing actually does require neatness. So be neat. Be neat. You'll lose points so easily just by being sloppy about it. Just be neat. Linear regression, that is golden points if you just learn how to do it, and it's a calculator problem. And this one's worth 4 points. That's worth 2 multiple choice questions by itself. So I'm going to do this one every single step. Do it with me every single step on the calculator. I'll tell you the app in a second. I did already, the Calc 84 app. Graphing, big one. If you graph it correctly, you could get 1 point. Graph both correctly, you get 2 points. Like lots of points here. And then part 4, 6-part problem with a lot of free points able to be gotten. A lot of free points able to be gotten. I'm telling you. Remember, 1 point is a half a multiple choice question. So if you could tease out a point from a problem you don't know how to do, or lie to yourself and thinking you don't know how to do it, you could tease out a lot of points out of there. Okay? Now, we're at the end of the test. Scrap graph paper, use it freely if you want. Like, it helps if you need to just kind of quickly draw out something. This, though, is where students just don't often go, but it's here. Like, it's a formula sheet. So Like students forget the formula for the area of a triangle. It's not a geometry class, but they could totally give you a triangle because they gave you the formula for it, the area. Parallelogram, area, circle circumference, general prism volume, cylinder volume, sphere volume, cone volume, pyramid volume, Pythagorean theorem. So they can even give you the Pythagorean theorem in an algebra test because they gave you the formula. Um, Quadratic formula, they definitely will give you that. Arithmetic sequence formula, you need it. Geometric sequence formula, geometric series formula, radians, which we don't use them in algebra 1, but in algebra 2 there. So they tell you how to the conversion factor between radians and degrees in 2 different ways. Lots of students don't know how they work, and they don't bother going into the back of the book to see it. Then exponential growth and decay, and then here conversion factors. Um, Inches to centimeters, meters to inches, miles to feet, miles to yards, miles to kilometers, kilometers to miles. If you use any of these as written, they allow credit. And if you happen to know them from outside of here, you could use those too. Pounds to ounces, pounds to kilograms, kilograms to pounds, tons to pounds, cups to fluid ounces, pints to cups, quarts to pints, gallons to quarts, gallons to liters, liters to gallons, liters to 1 cubic centimeter. And there is one formula that I think they should give, but they don't. And I don't know why they don't give it, because it's not truly a math formula. It's a density formula, which is from like chemistry, biology, physics, but they don't give it. But density equals mass over volume. And we'll talk about that when it comes up, and it will come up on this test. And so we've explored the test. So now you don't necessarily have to, other than this, you do have to go to the formula sheet. You don't have the excuse that I forgot the formula when it's in the back of the test. And some teachers, when you're taking the test, don't tell you, go to the back of the test and check. So now that we read it, you don't have to read it, hopefully, um, during the test. Now, a lot of people who create YouTube videos put ads in their videos. I, generally speaking, have done it in different ways. I will not advertise my business except for this one time. If you want to skip my ad, you know what? Do it. But this is the only time that I'll be giving an ad for my business, and no other place. Now I will be doing a freebie throughout that at one point in the video, so do pay attention to that. So, um, the first off, my website, my tutoring website is JuanTutors.com. If you go to my website and contact me, I have some free. I do have a free blog there. I have some free information there, and I do tutor. You know, that is what I do as a side gig. Uh, Feel free to contact me, and I do have other tutors as well. Here are some of my tutors in math. I'm not gonna lie to you. This is both a bit of a humble brag. This is both a bit of a humble brag and just reality. I do charge uh, an amount that actually allows me to work with more discerning clients. Now I am giving a freebie somewhere in the video, and I'll explain it later. Like I said, but I do tend to work with more discerning clients, and I do have tutors who work at different price points. I know that Michael, phenomenal tutor, MJ, phenomenal tutor, Stacy, also a phenomenal tutor, and I do have an English tutor, a clinical psychology PhD student, a really phenomenal person. She tutors for AP Psych, college application essays, etc. And Lisa is a certified ELA teacher. Phenomenal artist, Mr. Armstrong. I love these are things that you could do with kids. If you want to do some art tutoring for your child, or if you want to do some group art tutoring, he also does some group art tutoring. The two things that I love about these first two pictures here on top is that I'm like, he did it. Maybe I was like, maybe he did a photography thing, and it's not. These first two pictures on top are drawings. I mean, really phenomenal artist. And if you look at it, you actually, if you really zoom in, and I'm not gonna zoom in because you can go ahead and zoom in, juanstutors.tutorbird.com, or you could contact me and I'll send you the link. These look like drawings when you zoom in. It's when you zoom out, they look like like lifelike as a drawing can possibly get. And he can show you how to do that, which I think is phenomenal. And of course, he also tutors computer science as well as MJ, and some of the tutors that I've already also tutor some science. As I promised, that's my only ad. I may mention my company, JuanTutors.com, so don't accuse me of not of something else if I just happen to mention it. I will also mention my freebie in a little while, okay? But right now, we're gonna get started with the test. Now, the part ones, we're gonna read the top, the heading. We're gonna read the heading, and we're gonna so that you know what the heading says, but you don't have to read it every time during the test. You just because it doesn't really change, but it does say to answer all 24 questions in the first part. Each correct answer will receive 2 credits. No partial credit will be allowed. Utilize the information provided for each question to determine your answer. Note that the diagrams are not necessarily drawn to scale. But again, if you have no clue how to do the problem, assume they are. For each statement or question, choose the word or expression that, of those given, best completes the statement or answers. The questions. Record your answer on a separate answer sheet. Okay, now we go to question number 1. A cafe owner tracks the number of customers during business hours. The graph below models the data. And when I'm reading the problem, I look at the chart, I read customers, I see time of day, I look at the numbers briefly, and I look at the times briefly, and I see up, down, and I don't even, myself, I don't analyze it more because I know I'm going to go back to the diagram and read it again. Now, based on the graph, the cafe owner saw a continual increase in customers from 6 to 11, an increase in customers from 12 to 3, a decrease in customers from 1 to 4, and a decrease in customers from 11 to 2. And now this is going to be something I'm going to say repeatedly, but not every time. Do the problem before I do it. Get your answer, and with an answer choice chosen, explicitly written, and then see how I do it. Now, because of the magic of YouTube and the pause button, I don't have to sit there and wait. So I'm just going to do the problem. Now, it says here, continual. Let's see, increase in customers from 6 to 11, increase in customers from 12 to 3, or decrease in customers from 1 to 4, or 11 to 2. Now, I don't know, like, pretend me doesn't know the answer to the question, but if it says a continual increase in customers from 6 a.m., to 11 a.m., there's definitely a decrease in there. So this is definitely wrong. Borrow my notation. When I know an answer is wrong, I exit out at the number. Now, an increase in customers from 12 to 3, that's definitely an up and a down, so that's definitely wrong. So now, a decrease in customers from 1 to 4, or a decrease in customers from 11 to 2. So now I might be confused in there, let's say, so I might put a mark somewhere here. But now here's the thing. This talks about a decrease or an increase. Let's actually focus on the times. Let's use the blue pen for the decrease from 1 to 4. Let's see, 1 o'clock to 4 o'clock. 1 o'clock is here to 4 o'clock here. That sure looks like a decrease, right? So this is looking good. And then this one, a decrease in customers from 11 to 2. Here's 11. And here's 2 o'clock. I mean, it's from here to here. I mean, not only was there not a continual decrease, it went up and back down to the same exact spot. Okay, let's do that in red. Up and back down. Now, if you're colorblind, sorry, because I'm colorblind, I barely could see that. But this is definitely wrong. So the answer is definitely choice 3. Definitely choice 3. Okay? But notice the strategy that I used, I eliminated some of the choices. Every single problem, you should eliminate choices that are 100% incorrect. Numero dos, number 2. The expression 3x squared plus 4x plus 8, close parentheses, plus 2 parentheses, 11 minus 5x is equivalent to one of these expressions. 3x squared minus x plus 5, or 3x squared minus x plus 14, 3x squared minus 6x plus 14, or 3x squared plus 14x plus 14. Okay? Now, again, if you don't know how to do this problem, I mean, first, this is some of the basics of algebra at this point. Do the work that it takes to do the problem correctly. Don't skip any steps. A lot of students know how to do this problem, know how to do it, but because they try to find the most efficient way, not knowing that their teacher has already taught them the most efficient way. There are some strategies to getting to process of elimination. This is the first process of elimination problem for a multiple choice question using a calculator that I'm going to give you. Okay, so I'm going to reduce the size of the calculator, but I'm also going to get a detached LCD, view detached LCD, so you could see a nice big LCD. Okay, so this is an example of something I might do to eliminate some choices. I say, suppose I don't know how to do the algebra, but what would I say? What if x equals 0? If x equals 0, what if x equals 0? I didn't say that x is 0, but what if x is 0? The original expression is -8 plus 2 times 11. And everything else is where I plug in x, I get 0. 3 times 0 squared is 0. 4 times 0 is 0. -8, -8. 2 times 11 minus 5 times 0. 11 minus 0 is 0. 2 times 11. So -8 plus 2 times 11. Then I go back to my calculator, right? And I do -8 plus 2 times 11. And I get 14. So the answer is going to guarantee me that if I plug in x equals 0, I get 14. The first answer gives me a 5. The second answer gives me a 14. The third answer gives me a 14. The fourth answer gives me a 14. So now, even if I don't know how to do the problem, I have a 1 in 3 chance of getting it right. Now that's 1/3 of a multiple choice question instead of 1/4 of a multiple choice question, right? Oh, and by the way, the strategy that I just used, here's the point. It just keeps working. You could say, what if x equals 1? And if that doesn't eliminate every single choice, then you could say, what if x equals 2? What if x equals 3? At this point, at this point, you only need two lines. At this point, you will have enough information to get the answer right. So this is a foolproof strategy to get this answer, not just a process to eliminate one choice. Now, I'm going to actually do the algebra. Okay, so I need to get rid of the parentheses. One trick a lot of students like is to put a 1 in front so they have something to distribute, because there is no 1 in front. There's no number in front. And here, the 2 can be distributed. And I get, let's see, 3x squared without parentheses plus 4x minus 8. Now I'm going to distribute the 2 plus 2 times 11. So plus 22 minus, and this is where a lot of students do distribute but get it wrong. They forget to multiply the 2 by the minus 5x, so minus 10x. That's a big place where students get it wrong, okay? Now I see the 3x squared. Every choice has a 3x squared. Now I'm going to combine the x's. I get plus 4x minus 10x is minus 6x. And then minus 8 plus 22. And then the minus 8 plus 22 is plus 14. So 3x squared minus 6x plus 14. And there is my answer. So now we learned how to get the answer without knowing how to do the problem. What if x equals 0? What if x equals 1? What if x equals 2? What if x equals 3? Till you get the final answer. And we also know how to do it with algebra. Okay? Big deal. Big deal. That's... So I'm sorry if I'm going to try to eliminate all my coughs in between. But if I'm literally getting over COVID, and I am negative, and have been negative for a week and a half. My lungs are shot. All right, numero tres, number 3, wearing a new hat. There's my hat. So there's the hat that I was wearing. I promise that's relevant. Which point is a solution to y equals x cubed minus 2x? -3, -21, -2, 10, 1, 1, or 4, 2. Again, do work until you get an answer for yourself, and then see how I do it. I'm going to say that again, and I'm going to say it a few more times too, but do get an answer until you keep going until you get an answer, and then see what I did. And now with the magic of YouTube, I could just, without pausing, I'm going to keep going. But I will tell you this. I gave you advice for number 2. That advice still applies for number 3. You just absolutely can plug an answer in and see what you get. So what I'm going to do without knowing how to do it, I mean, look, that's actually how to do the problem. That's kind of the point. Now, I will say this. I have some suspicions on what might be incorrect. I have a suspicion that this one is going to be incorrect. In fact, I'm going to check it real quick. If I plug in a -2, I get a big negative number. It's going to stay negative. This is going to guarantee to be wrong. That's my process of elimination. Okay. This one, I'm going to take a 4 to the third power. This, nothing can overcome the fact that 4 to the third power is 64. This is a huge number minus a small number. This, unfortunately, is going to be guaranteed to be wrong. Okay. So now I'm going to choose. Now I'm going to choose one of these, 1 or 3, to plug in and see if I get the right answer. Now I will choose. I'm going to test. This is how to do it now. That's what they want us to do. Otherwise, we really can't do it. But I will also say this, that the calculator could do this for you. So I'm going to show you how to do this on the calculator afterwards as well. But I'm going to try problem choice 3. And I'll tell you that this is the most common incorrect answer. If I plug in 1 for y and 1 for x, I get 1 equals 1 cubed minus 2 times 1. And so students get 1 equals 1 minus 2, and they swear that 1 minus 2 is -1. I'm sorry, they swear that 1 minus 2 is 1. And 1 minus 2 is -1, but they get it wrong. 1 minus 2 is equal to -1. This is false. So choice 3 is incorrect. Okay, and so then the answer is choice 1. But I'm going to show you how to do this problem on the calculator and verify that it's choice 1. Okay. Turn the calculator back on. Y equals, let's clear this over here. And it's y1 equals, let's see, x cubed minus 2x. Okay. And then you could actually go to the table. Let's see if the table's set up right. And then you can scroll up and down. So if you can't scroll up and down, then you see in blue over here, it says table set in blue. So you press the blue second button and you go to table set. You could say, you could do table start at 0. Say delta table is 1, and change the independent and the dependent both to auto. It is valuable to know how to use the independent as asked. I've never changed dependent to ask. Never do that. Don't. I don't know why it's even an option. Well, I do know, but you could change the independent to ask, but right now we're going to change it to auto. And now you can actually scroll up and down to see the value of y. Let's go for choice 1. X is -3. Y is -21. There's our answer. To verify, X is -2. Y is -4, not 10. X is 1. Y is -1, and X is 4. And there's the answer. Maybe that's why people chose 4 too, because they let X be 2 and Y be 4. And that they will look for you doing that. Don't mix your X's and Y's. These are ordered pairs, X, Y, in that order, alphabetical order. And then choice 4, when X is 4, Y is 56. So that's how to do it using a calculator. Super duper. I've had one hat change, right? Promise it's relevant. I promise it's relevant. Number 4, what is the value of X in the equation 5 parentheses 2x minus 4 close parentheses over 3 plus 9 equals 14? X is 1.9, 3.5, 5.3, or 8.9. How many students get this question wrong and don't bother doing it on the calculator? How many students get this wrong? You could literally just plug into your calculator. That is my process of elimination. That is my advice to you. You could plug it into the calculator and get the answer. Now, there is some work you can do preliminarily to do some guessing strategy. For example, if X is 8.9, the 2x minus 4 is going to be strictly greater than 8.9. Way greater than 8.9. Divided by 3 is going to be greater than 3 times 5 plus 9 is going to be way bigger than 14. So that was correct math, correct estimating, way bigger than 14. Now, the 5.3, my estimating skills, this is fake student me, not real teacher me, When I say fake student me means I'm simulating myself as a student. Real teacher me knows that choice 3 is incorrect. But fake student me says, oh, I can't visually estimate what the value of the left side is going to be, but I have a feeling that 5.3 is still too big. So I put an X next to it, as opposed to when I cross out the actual choice 4. This is where you can borrow my notation. Choice 4 I know is wrong because when I plug it in, I'm going to get an answer that's way bigger than 14. Can't be right. But 5.3, I'm estimating looks a little bit too big. Now 3.5 and 1.9, I can't evaluate. Just my fake student me estimating skills are just not quite up to snuff. But now I'm going to do the algebra. Okay, so 5 parentheses 2x minus 4 over 3 plus 9 equals 14. Let me just repeat again. You could literally just plug into your calculator. Just plug in carefully. I know so many students skip parentheses because they just want to out of laziness, but they're there. It's math. Don't skip your symbols like parentheses. Duh. Right? Okay. So now I'm going to subtract 9 because I'm doing the inverse operation method. Another thing that students do is they skip the subtracting step and they just try to do it in their head. They start talking about moving and things like that. Your teacher shows all steps most likely, or tells you to show all steps. You should show all steps. When no one's looking, when I'm saying no one's looking, when I'm solving as an expert in math, when I'm doing math problems on my own, I show all of my steps because it's more efficient. It's actually faster, but it's also more accurate. And I get 5 parentheses 2x minus 4 close over 3 equals 5. Okay? Now I can multiply both sides by 3. Multiply both sides by 3. Oops. And that is an error there, 3. Okay. I get 5 parentheses 2x minus 4 equals 15. Now, the 5 is being multiplied. There's 2 ways I could go about it. Inverse operation method says I could just divide by the 5, but this is because of my tutoring experience. For some reason, students get it wrong when they divide by 5, but they get it right when they distribute. So I'm going to distribute 10x minus 20 equals 15. Now the 20 is being, where students get this wrong also is they forget to multiply the 4 by 5. So multiply the 4 by 5. Add 20, because that's the opposite of subtracting 20. I get that 10x equals 35. Now I could divide by the 10. And I get that on my calculator, x equals, and this is where predict but verify becomes relevant. Predict but verify just means this. I always tell my students to not just assume the answer, but also to not trust their calculator. So they have to predict but verify. I have to quit in blue. So I press the blue second button and quit. And I do 35 divided by 10. And I get 3.5. For a problem that could be done on the calculator, that was a lot of work. But the point is, you can do it on the calculator, but you also, like I told you, I want to do every problem for you on paper so that you know how to do it as well. Because there's going to be problems that you can do it on the calculator, so go ahead. But there's problems that look very similar, but just a little tweak in it doesn't allow you to do it in the calculator, but allows you to do it on paper. Vice versa, there's going to be little tweaks in problems that don't allow you to do it on paper, but do allow you to do them on the calculator in one way or another. I mean, I think this is a great example. Well, this one, you could do it on the calculator or the arithmetic on paper, but as an arithmetic problem, it's not an algebra problem, it's an arithmetic problem. So it's just calculating, either on paper or calculator. You can't do this problem algebraically. You could just evaluate, which is arithmetic. Okay? Numero 5, number 5. The graph of y equals f of x is shown below. Which of the graphs represents y equals f of parentheses x minus 2 close parentheses plus 1? Now, it's either this graph, choice 1, or it's this graph, choice 2. Let me just maybe expanding it a little bit. Choice 3 or choice 4. Now, again, use correct math to make predictions. I always say this, and I know I'm going to say it a few more times, but even if you don't know what this is talking about, you actually might have enough information to at least eliminate two choices. I think you could eliminate two choices. So I'll tell you this, if you don't know how to do this problem and you're listening to me, pause, eliminate two choices using correct math, at least two choices, and then see if you eliminated the choices that I do. Okay, so now, how am I going to eliminate the two choices? Fake student me says, I don't remember what the teacher said about this x minus 2. What does the minus 2 do? But I remember what the plus 1 does. So if you remember, pause and eliminate two choices. But now, I remember that the plus 1 is going to move the graph up 1. This graph, choice 3, is moved down 1 below the x-axis. That can't be it. And this graph moves down 1 below the x-axis, and that can't be it. Now I have a 1 in 2 chance of getting it right, worth a problem that was worth a quarter of a multiple choice question with a wild guess. Now is worth half a multiple choice question with a wild guess. If in every question I can eliminate two choices, then I go from getting 1 in 4 of the questions right, which is 6, to getting 1 in 2 of the questions right, which is 1 in 2 out of 24 questions is 12 questions. You only need 13 to pass. So that's worth our time. So now I can guess from this. So now how to do the problem. So this is, if you just accept this blankly, you will get the questions right. Because I can sit there and teach why this works. But if you do this, if you transform, now this is a true transformation. Try not to use an arrow symbol when an equal sign is appropriate. You should really only be using arrows when you're actually changing something. So if f of x is transformed into f of x, close parentheses, plus k. So I'm adding a number outside. This is moving k units up. So if I'm adding 1, that moves the graph k units up. Okay? So I'm moving the graph k units up. So that f of x transformed to f of x plus 1. I'm moving the graph k units, 1 unit up. Okay? So that eliminated correctly two choices. Okay? Great. So now what about if the inside? What happens if I modify x? Okay? So this is the part that trips a lot of students up, but if you actually just accept it as gospel, I don't like that, but the thing is that we could prove it to you and prove it to you and prove it to you, but at some point you do have to remember certain things, and I can't prove everything in this Regents. That's not what you're here for. You're here to improve your score maximally. So here's the thing. If you modify x minus h, every operation that you do to f of x outside, like the plus k, does what you might expect it to. Add 1, moves it up 1. Add 3 outside, moves it up 3. Subtract 7, moves the graphs down 7. Well, it turns out that every modification you do to x has the opposite effect as what it would outside. So this moves or translates the graph h units. So if I'm subtracting, you might guess, because if you subtract in the y direction, it moves it down. So you might suspect if you subtract to x, it might move it to the left. And it doesn't. It doesn't move it to the left. It moves it to the right. Okay? And if you accept that every transformation has the opposite effect in the x direction as it would if it were done outside in the y direction, then you can get every question right. So that f of x transformed to f of x minus 2, this moves the graph 2 units, not to the left, but to the right. Okay, so now we actually have a way to do this problem. So this point here moves up 1 unit and to the right 2 units. And now we have our graph. We have our new graph. So this graph, we're going to have a point here. This point is going to move 1 up and 2 to the right. This point here is going to move 1 up and 2 to the right. This point here is going to move 1 up and 2 to the right. This point here is going to move 1 up and 2 to the right. You're going to have this parabola. And that is choice 1. Choice 1. And I want you to remember that whatever you do to x has the opposite effect as a transformation as what it would if you do the transformation, if you do the operation outside. Like literally, +1 outside moves the graph 1 up. +1 inside to x moves the graph to the left in the negative direction. 1 unit. +5 outside moves the graph up 5. +5 to x moves the graph in the negative x direction, 5 spaces. Remember that, like gospel, and you get everything right. Now, if you feel like this video is helping you, look, this is probably a lot of information that you didn't know. And I promised you that the beginning was my only piece of advertising. This is not advertising. This is my only request from you to subscribe. You should actually see right around here, probably a little picture of my face that's clickable for you to subscribe. At least that's the way that YouTube works right now. If you click on that, subscribe, it helps my subscriber count. I don't put out a lot of videos, so you're not going to be bombarded with my videos, but it's the thing that allows me to do this one piece of work for you for free. Like you know that I do work for usually more discerning clients for tutoring, but this piece of my work is free. And I've always wanted to have an arm of my business be free and an arm of my business not be free. And this is the arm of the business that is free. I do this for you so that people who grew up like me, or maybe didn't grow up like me, but I grew up very poor. I never had tutoring because I couldn't afford it. No one in my family could afford it. Barely could afford the pizza. Like that was a big luxury for me. And I used to put the reason I love spicy food now, by the way, is that I used to put hot pepper flakes on my pizza so that I would have more food to eat. Like that's how I grew up. And now I'm doing really well for myself and I'm really proud of myself. It took a lot of hard work and I'm there. Having my subscribers allows me to put ads on my videos, which allows me to make a little bit of money off of this. And that's how you pay me for this video. So that's my big request. So if you could do that, I would really appreciate it. And if you feel that at this point that I've earned your subscription, thank you so much. Now I will say this: there is a second piece that of free content that I have, and this is where the hat change is relevant, and this is now where I'm explaining it to support you in your journey of improving not just on the Algebra 1, but on the Geometry and the Algebra 2, and also on the SATs. In the description of this video, there is a link to a sign up for a totally free daily SAT/ACT assignments. So daily 20 minutes all on your own, and it's all automated with videos. I set up the assignments. Click on the video, click on the link and sign up for that. Again, you may get occasional emails, but the emails aren't even just advertising. I do not bombard people with advertisements. I don't believe in it, and I don't have to, so I don't. But every email that you get will be with advice. And yes, it may say, "Hey, this is my tutoring company," but the truth is that the body of the email is always gonna be advice. Okay, so go into the description, sign up for the free SAT/ACT practice assignments. In that, I ask you to answer a question, which I will ask later, okay? Somewhere in the video to reward you for having paid attention to everything that I've said. All right. And if you subscribe, thank you very much. I had another hat change, number 6. The length of, numero seis, the length of a rectangular flat screen television is 6 inches less than twice its width. If the area of the television screen is 1,100 square inches, which equation can be used to determine the width in inches? X times 2x minus 6, or x times 6 minus 2x equals 1100, or 2x plus 2 times 2x minus 6 equals 1100, or 2x plus 2 times 6 minus 2x is equal to 1100. And so, as I said, try the problem, answer the question, and pause and try the question and make sure you choose an answer before you see how I do it. If you don't know how to do the problem, use your process of elimination to eliminate the choices that you know are wrong for a fact using correct math, okay? And then answer the question. Now it says the length of a rectangular flat screen television is 6 inches less than twice the width, x. So the width is x, and the area of the television screen is 1100 square inches. Which equation can be used to determine the width in inches? Okay, so now just to go back to this, because again, I remember I told you to go to the formulas. There is a formula sheet at the end of the video. So do you have an excuse to not know the formula relating the area and the perimeter, etc., of a rectangle to its properties? You unfortunately will hear the formula for the area of a parallelogram is base times height. They don't tell you the formula for the perimeter, but they tell you the formula for the area. And the rectangle is a parallelogram. So you do need to know that one, okay? It does say that the area, I need my other pen. The area is 1100 square inches. So if I remember that the area is equal to the base times the height, then that actually, even if I don't remember how to do the problem, that is enough to eliminate two choices. Because if I remember that the perimeter is equal to 2 times the length of the base, plus for a rectangle and plus 2 times the height. So even if I don't know how to do the problem, these are going to be guaranteed to be wrong. Now I know for between two choices. Okay. So now it says that the area is 1100. Let's write, this is now me doing the problem. The area is 1100. Now, how I do the problem, I like to write a word equation to help me do the problem. It says that the length of the rectangular flat screen is 6 inches less than twice the width. So the length is equal to 6 inches less than twice, so 2 times the width. So the width is equal to x, okay? So x, and I'm gonna use the length for L, and 6 inches less than, this is where students get tripped up. So if you think about 6 inches less than something, are you doing 6 minus the thing, or are you doing the thing minus 6? And this is where know what you know and know what you don't know is relevant, because if you think 6 inches less than, and you might say to yourself, well, that means 6 minus, or is it 2 minus the other thing minus 6? But think about $6 less than 100. That's 100 minus 6. It's not 6 minus 100. $6 less than $20. That's 20 minus 6 is 14. So it's actually, I'm subtracting 6. So it's 2x minus 6. So the length is equal to 2x minus 6. Okay? And so then the area is equal to the length times the width. So the area is equal to the 2x minus 6 times the width, which is x. And I have to look at which formula matches that. And by the commutative property, I have the 1100, the area is equal to, well, 2x minus 6 times x, or by the commutative property of multiplication, x times 2x minus 6. By the way, sorry that I blocked off a little bit of the writing on this one. That was accidental. Let's see if I can bring this down a little bit. All I wrote was that L equals 12 plus L equals 2x plus 6. Sorry about that. I'll make sure to keep an eye on that for the rest of the video. Numero siete, number 7. A box plot is shown below. Which number represents the third quartile, 30, 50, 60, or 75? choose an answer here. I hope that you do get this question right. It is something that comes up so often, but even if you don't know what this thing is talking about, you might be able to actually guess the third quartile based on just the name of the thing, where it is. Okay, so now if I happen to know a little bit of about the graph information, what some parts of it mean. Now I happen to remember that this is the min, this is the median, okay, and that this is the max. So this is me using process of elimination. So based on my process of elimination, again, you want to select your answer before you hear me say this. But I know that the median is, the third quartile is not going to be 15. That's not a choice. I know the third quartile is not going to be the median, so it's not 50. And I know that the third quartile is not going to be the max, which is 75. So it's not 75. So now I have 2 choices left, which is phenomenal. Phenomenal. I have 1 and 2 chances of getting it right. So now based on that, see if you get the answer. Now, how does it work? The min is Q0. The first quartile is Q1. The second quartile is Q2. The third quartile is Q3. And the fourth quartile is Q4. Okay? Or the max is Q4. So which one is the third quartile? Well, it's the third one, right? It's the 60. So I want you to remember that. So it goes min, Q1, median, Q3, and max Q4. Or in other words, Q0, Q1, Q2, Q3, Q4, where the min is Q0, the median is Q2, right? Halftime, Q2, and max is Q4. That's the end of the game. Numero ocho, number 8. What is the product of 2x plus 7 and x minus 3? So, well, 2x squared minus 21, or 2x squared plus x minus 21, or 2x squared plus 4x minus 21, or 2x squared plus 13x minus 21. Now, definitely, think about which one you think the answer is, and then make a guess based on that. I will say this, there is some information that you could use to make a prediction. A good question is, can you do this one on the calculator? And you absolutely can. And I'm going to show you how to do this one on the calculator first. I would then continue on to see how I do the problem for the rest of the video. So, but one way you could do this is by choosing values of x, just like we did before. What if x equals 0? Okay, so now if x equals 0, then you get the product is multiplication. Okay, so if x is 0, you get 2 times 0 plus 7 is 7. 0 minus 3 is negative 3, and you do get negative 21. Now, if you go through all of them, if x is 0, you do get negative 21 for all of them, but that's actually rare. They usually don't do it that way, where you can't just plug in 0 and eliminate at least one choice. So it is worthwhile to plug in 0. So what if you do what if x equals 1? Then you get 2x plus 7, so 2 times 1 plus 7 is 9, and 1 minus 3 is negative 2. Now, if you didn't know that, go to the calculator, predict but verify, do 1 minus 3 on the calculator, you get negative 2, is equal to negative 18. So let's see which of these answers gives you negative 18. Let's see, and let me open to my book just so I make sure I don't get anything incorrect here. So which ones give you negative 18? So the first one, if I plug in x equals 1, I get 2 times 1 squared is 2 minus 21. Again, just to simulate me as a real student. So fake student me says 2 times 1 squared minus 21 is negative 19, which is not negative 18. So that's wrong. What about the second one? 2 times 1 squared plus x plus 1 minus 18, minus 21, sorry, minus 21, is negative 18. So it could be choice 2. This is looking good. Now, how about the second one? is 2 times 1 squared plus 4x. 4 times 1 minus 21. This is not looking promising. I got negative 15. And then this one, I'm going to be guaranteed not to get negative 18, but, let's simulate it here, okay? 2 times 1 squared plus 13 times 1 minus 21 is negative 6, not negative 18. So it's got to be choice 2. Now, I want to make sure to reward you this time and then another time for watching how I do the algebra, okay? So, but the answer we know already is choice 2. So, but let's verify it. 2x plus 7 times x minus 3. We do FOIL or each with each. The 2x gets multiplied by the x and the minus 3. And then I got 2x times x plus 2x times negative 3. Okay? And then also, let's use this color, this crazy color, 7 times x and also the 7 times negative 3 plus 7x plus 7 times negative 3. I'm a fan of circling. I shouldn't have used this color. I'm going to change it to something that's more legible. Okay? So, and then we simplify. So 2x times x is 2x squared plus 2x times negative 3 and negative 6x, negative 6x plus 7x plus 7x. And then plus 7 times negative 3 is minus 21. So 2x squared plus minus 6x plus 7x. Negative 6 plus 7 is 1. So plus 1x minus 21. So 2x squared plus x minus 21. And that's how to do it algebraically. So hopefully you watched how I did it, and hopefully you get rewarded by that, and hopefully you continue watching how I do other problems. How many hats are up there? 2 so far? And so this is my 3rd hat that I'm wearing. Number 9. What is the degree of the polynomial 2x plus x cubed plus 5x squared? Is it 1, 2, 3, or 4? All right, so a lot of students do get this one wrong because they were told to do something in class and they decided not to do it because they keep skipping steps that teachers tell them to not skip. So let's keep that in mind. And when we're doing this problem, there are just things you're supposed to do. So is the degree 1, 2, 3, or 4? Remember the advice that I gave, which is know what you don't know. Know what you don't know. There are things that you're just not supposed to do. Don't do the thing that you're not supposed to do. What is the degree of the polynomial 2x plus x cubed plus 5x squared? Well, okay, so now in terms of the process of elimination, there is nothing here that could make this a degree 4 polynomial. So that one is definitely just not the answer. There's nothing here. Now, I might be forgetting how degrees of polynomials work, but I also know I have a 2x plus an x cubed plus a 5x squared. The degree is definitely not 2 because I know that it's either 1 or 3, and I'm just trying to remember, fake student me is trying to remember what the teacher said and how to do this problem. So it's either 1 or 3, but it's definitely not 2, and there's no way for it to be 4. But so now based on that, now hopefully you get an answer, but definitely choose. Remember what I said, answer, and I'm eventually going to stop saying this, but answer the question yourself before you see me do the problem. If you didn't do that before, now choose between 1 and 3 and see which one you select. Now that said, how to actually do the problem, the degree of the polynomial is the degree of the leading term. But what is the leading term? The leading term is the first term when the terms are put in decreasing degree order. So the first term would be the highest degree term is x cubed. Then the plus 5x squared is the next degree term. And then finally the linear term is the plus 2x. And so then the degree is the degree of this term. And so the degree is 3. All right, numero 10, number 10. What is the solution to negative 3 parentheses x minus 6 greater than 2x minus 2? Now, just a quick lesson. Again, a lot of students just forget this, but Pac-Man eats, or the alligator mouth eats the bigger number. So 5 is greater than 1, right? And let's do also like 7 is less than 20. Okay, so the origin of this symbol is not a Pac-Man mouth. And if you haven't played Pac-Man, like the teachers talked about Pac-Man mouths when I was a kid, but we played Pac-Man when we were kids. We don't really play Pac-Man anymore. But we know what a goldfish eats, so we know we could talk about goldfish mouth or alligator mouth, whatever it happens to be. But if you don't see the greater than or the less than symbol as a mouth, what you could think about it then instead is actually the origin of the symbol. The origin of the symbol is literally a line and another line, and their lines are closer together. So this is the smaller side, and here the lines are further apart. So this is the bigger side. And that's how the symbol works. The side with the lines open more is the bigger side, and the lines where the lines are closer together is the smaller side. Okay, so that's actually how the symbol works. So even if you don't remember how to read the symbol, you know which side is bigger. And then the second thing is to remember that on the number line, even on the negative side, these numbers are less and these numbers are greater. No matter what, further to the left is less, further to the left is less, and further to the right is greater. Okay, so what is the solution set to negative 3 parentheses x minus 6 is greater than 2x minus 2. Now, I might not know how to do this problem, but I notice that, so for process of elimination, 0 is missing in some of these solution sets, and 0 is part of the solution set. So I'm going to test x equals 0, and I get negative 3 times 0 minus 6. Is it greater than, question mark, 2 times 0 minus 2? So I got negative 3 times negative 6, and I should use my calculator. I get 18. Calculator, use your calculator. Don't be scared. Use your calculator. Is it greater than negative 2? 2 times 0 minus 2 on the calculator is negative 2. This is a big yes. Remember, I didn't touch my calculator, but I can't keep simulating the calculator because you need to watch a video. So you should use the calculator to do 3 times 0 minus 6. No, negative 3 times 0 minus 6. Okay? So don't be lazy about it. Like a lot of students are obsessed with using the calculator right up until the point where the teacher says use the calculator, and they're like, no. So 0 is part of the solution set. So now I check. Is 0 greater than 4? No. Is 0 less than 4? Yes. Is 0 greater than negative 16? So negative 16 is somewhere over here. Yes. Because the greater side is to the right. Greater side is to the right. The lesser side is to the left. And is 0 less than negative 16? No. So there's two definitions of size that we use. And that might be part of the cause of a lack of intuition. We use them in Algebra 1 as well. So pay attention to this. Point is, your intuition is not incorrect. One definition is the number line definition. Numbers to the left are lesser, numbers to the right are greater. And it might seem like, well, you're saying that negative 1,000,000 is less than negative 10? That doesn't feel that way. Well, that's because of your intuition of one of the two definitions. But the thing is, would you rather owe somebody $1 million, or would you rather owe somebody $10? Clearly, you would rather owe them $10. Owing somebody $1 million is whack. I don't owe anybody $1 million. Well, I'm really glad about that because that's a lot of money. That's a lot of money to owe. So a negative $1 million is less than negative 10. So numbers to the left on the number line are definitely less. Okay. But the other definition is the absolute value definition. How far something is from 0. Negative 1,000,000 is definitely, it's like if you have a hole that is 20 miles deep versus a building that's 2 stories tall. Well, the 20 miles deep hole, that's a really giant hole, and a 2-story building is not terribly big. So it can feel like that 2-story building is smaller than the 20-mile hole. Well, in a certain sense, it is in absolute value. So in absolute value, that hole is giant, 20 miles down versus 2 stories tall. Just the same way, a negative million in absolute value is a huge number in absolute value, but it's not bigger in actual relative value. Owing $1 million and owing $10, I'd rather owe $10. I have more money if I owe $10 than if I owe $1 million. So that's why the intuition is not incorrect. It's the definition. The less than symbol and the greater than symbol are an ordering on the number line, not an absolute value. Okay, so I've eliminated two choices. Now I could do the algebra. Okay, and let me make sure that I am not writing under my picture. Let me change my pen color here, just so we have, so -3 parentheses x minus 6 is greater than 2x minus 2. Okay, let's distribute here. -3x, and now calculator, if you don't remember about know what you don't know, a lot of students don't know if -3 times -6 is plus 18 or minus 18, and then instead of going to their calculator, they just take a guess, but they have their calculator. -3 times -6. There we go, simulated the way you would do it on the test, plus 18 is greater than 2x minus 2. Subtract 2x, subtract 2x. And then a lot of students don't know if -3 minus 2 is 5 or -5 or 1 or -1, and then they don't go to their calculator again. I can't do too much simulation, right? But -3 minus 2 is -5. So -3x minus 2x is -5x. Plus 18 is greater than -2. And then a lot of students, when they're subtracting 18 to get rid of that plus 18 is greater than, they don't know if -2 minus 18 is 20 or 16 or -16 or -20, and they don't go to the calculator, they just guess, when they could just do -2 minus 18 is -20. Okay, you should predict but verify. I predicted -20, I got it right, -20. I divide by -5, and this is where, this is again, now predict but verify. I think I remember my teacher saying that when I divide two negatives, the result is positive, but I predict but verify. So I think -20 divided by -5, I think it's going to be 4, positive 4. And I get 4. And this is where students actually get messed up here, because I get x and I get a 4 here. But now this is the part that students get messed up in. This is so important here. When you perform the action of multiplying or dividing by a negative number, the inequality switches direction. Okay, so I divided by a negative number. So the inequality switches direction. When you multiply or divide by a negative number, the inequality switches direction. Okay? So the answer is x is less than 4. Okay? I know it's a little trippy, and again, I could sit there and simulate it, but that's not the purpose of this video. So just remember that if you multiply or divide by a negative number, the inequality switches direction. Okay? Don't forget about this little button over here. The three expressions are shown below. 1, x cubed cubed. 2, x to the 4th times x to the 5th. 3, x to the 10th times x to the -1. Which expressions are equivalent for all positive values of x? Can be done on the calculator. Put them all, it's y1, y2, y3, and see what you get for the value of y. Literally. Y equals, clear, x cubed. I need parentheses. Parentheses, x cubed. Close the parentheses, cubed. Okay? Then you put the second one and the third one in the calculator. So I'll do the first two for you, and you have to go through the third one. X to the 4th times x to the 5th. And then you put the third one. I'm not going to do all the work for you. You got to participate, but you go to the table and see if you get the same number. And in fact, 0, 1, 5, 12, 19, 683, these are identical. These are identical. So 1 and 2 are identical. These are equivalent for all positive values of x. Now, an important piece is that they did say all positive values of x, and I just want to reestablish that. They did say all positive values of x. A lot of students get it wrong, but the point is that 1 and 2 are definitely equivalent. So anything that doesn't mention 1 and 2 is incorrect. 1 and 2, 1 and 2. So now the only debate is whether 3 is equivalent to 1 and 2. Okay, so but we've eliminated 2 choices, and you can get the third one the same way I just did. It's just typing in the third one. Use your calculator. And so that turned a problem that you don't know how to do, suppose you don't know how to do it, into a problem that you can do despite not knowing how to do it. That's why you're watching this video. You see that? That's why you're watching this video. So here, why is this? Why are these equivalent? This one, x to the third, this is equivalent to x to the 3 times 3, which is equal to x to the 9. So a power to another power, you could keep the base and multiply the exponents, okay? This one, x to the 4th times x to the 5th is equal to x to the 4th plus 5 is equal to x to the 9th. So if you're multiplying powers with the same base, you keep the base and add the exponents, okay? And what about the third one? Actually, it's the same rule. X to the 10th times x to the negative 1, x to the 10 minus 1, and that's equal to x to the 9th. And if you're multiplying powers at the same base, you keep the base and add the exponents. They didn't even bother changing it into a division to make it even harder. So in fact, these are all x to the 9th, and that's they're all equivalent for positive values of x. Why does it matter for positive values of x? Well, because if x is equal to 0, 0 to the negative 1 means 1 over 0. 1 over 0 is just undefined, right? You can't define 1 over 0. Okay, now Jim uses the equation a equals p times 1 plus 0.05 to the t to find the amount of money in an account A of an investment P after t years. For this equation, which phrase describes the yearly rate of change? A decrease by 5%, a decrease by 0.05%, an increase by 5%, or an increase by 0.05%. Okay, so even if you don't know how to do this problem, I think if you remember a little bit with exponential problems or a little bit with this, you might be able to actually eliminate 2 of the choices, decrease or increase, and either 5% or 0.05%. So I see a 1 plus 0.05. So my process of elimination says even if I don't know how to do the problem, it's a 1 plus 0.05, and that's going to be a definite increase. So that eliminates any choices that are decreases. Now, fake student me is saying to myself, I feel like I remember something about like that not being the percent, like the percent has to be turned into a decimal. So I think that when this one says 0.05%, I think this one is wrong. That's why I put an X next to it, but I'm not sure. Now, this one can be done on the calculator by just putting the value after 0 years and then a value after 1 year and then see if it increased by what percent. Like if P is 100, after 0 years, the value A is 100. And then after 1 year, the value A. So this is my advice. Try P equals 100, and then T equals 0, and T equals 1. And you see that here, that P will be equal to 105. That actually is an increase of 5%. So it should be 5%. And in fact, R is equal to the increase as a decimal. And if I remember how to convert a 5% into a decimal, is equal to 5 over 100 is equal to 0.05. That's equal to R. So yeah, it's definitely an increase by 5%. Number 13, numero 13. What are the zeros of m of x equals x times x squared minus 16? Yet another problem that you could do on a calculator. Plug them in one at a time. You get 0. A lot of students get this question wrong. With a calculator in front of them, see, now this is advice that I'm giving. Like, now this is me. This is not a soapbox thing. This is a statement about effort. A lot of students have a tendency to minimize the amount of work that they have to do, thinking that maybe for whatever reason, either thinking that teachers are trying to find a complicated way of doing things and they just keep trying to simplify what the teachers are doing, or really just being a bit, unfortunately, lazy, like for themselves. So like a teacher tells them to do a certain amount, and they decide to do less. Always, they try to cut corners as much as possible. So like the teacher tells them, don't use a calculator all the time, and the kid is like, well, I'm going to use a calculator, and then the teacher's like, well, use a calculator, and the kid's like, no. What? Why? Why do students put down the calculator when the teacher says use the calculator, and then they pick up the calculator when the teacher says don't? It's silly. This problem, you can do this one with the calculator. Go ahead, plug it into the calculator, see what you get. So many students are like, they see the x squared minus 16 and they think 8 squared is, and they get it wrong. They get it wrong because they just assume the value of 8 squared when you have a calculator in front of you. I mentioned the Calc 84 app. Go get your Calc 84 app out. Do 8 squared. Make sure it's not 16. 8 squared is not 16. 4 squared is 16. 8 squared is 8 times 8 is 64. 8 squared is 64. Okay? So anyway, so I'm looking at this x times x squared minus 16, and I plug in 0, and I get 0 when I plug in 0. So I know that 0 has to be an option, and that makes number 1 and 2 wrong, okay? Because they're missing 0. Again, what did I do? With my calculator, m of 0 is equal to 0 times 0 squared minus 16, and this is equal to 0 times negative 16, which is equal to 0. So 0 is definitely a 0. And I did it on paper, but fake student me did it on the calculator. So what about how to do this on the calculator? Plug in x equals 4, and you get 4 squared minus 16 is 0. So 4 is definitely it. And 8 squared is 64, so that's not going to be it. So the answer is going to be this. But again, for the second time in a row, I'm rewarding you for watching me do the problem algebraically. I seem to be training you to watch me do these things on paper for some reason. I wonder if there's a reward for it besides just a better grade. X squared minus 16 is equal to a difference of 2 squares, which a lot of students call these dots. Dots or dots, difference of perfect squares. I like difference of 2 squares for reasons that are motivated in like algebra 2 and pre-calc and calc. So difference of 2 squares. So what is 16 squared? So that's x squared minus 4 squared. Now the dots says this, a squared minus b squared. A lot of students want this to factor this incorrectly and get it wrong because they think it's like a minus b squared, but it's not. It's a squared minus b squared is a plus b, a minus b. A squared minus b squared is a plus b, a minus b. So x squared minus 4 squared is, well, x is a, b is 4, is x plus 4, x minus 4. So that m of x is equal to x, parentheses, x plus 4, x minus 4. And now we're trying to find the zeros of this equation. And, well, the first one, x is 0. Well, that's a 0-step equation right there, proving that x equals 0 is a 0, right? And then the next one, x plus 4 equals 0, subtract 4, you get x equals negative 4. And here, x minus 4 equals 0, plus 4, and you get x is equal to 4. And those are your zeros. Choice 3, as we said, okay? I seem to be priming you for something by doing the algebra after getting the answer. It's almost like I'm doing it on purpose. Numero 14, number 14. For which function is the value of y the intercept? Let me try again. For which function is the value of the y-intercept the smallest? X, f of x, h of x, g of x, or k. So I see that choice 1 and 3 are tables, and choice 2 and 4 are functions. So how can I do this? If I don't know how to do this, I should just, I do have to know what the y-intercept means, but the y-intercept is the value on the y-axis. And you need to know what's special about the y-axis. For every point on the y-axis, x is equal to 0. So I look for x equals 0 for the y-intercept, and I look for x equals 0 on the y-intercept, and I'm looking for the smallest Well, the y-intercept of f of x is definitely bigger than 2. 3 is bigger than 2, so choice 1 is not the answer, okay? And now that I know that x equals 0, I could just algebraically plug into g of x is equal to absolute 0, close absolute value, plus 4. And if I don't remember how the absolute value works, probably absolute 0 is still 0. So 0 plus 4 is 0 plus 4, which is equal to 4. That's not 2, so choice 2 is eliminated. Now, if I don't remember how exponential functions work, this is where I can get in trouble. A lot of students get choice the 5 to the 0 wrong, but it happens to be that they format it in a way that you kind of get lucky. A lot of students get k of 0 wrong. They just get it wrong, but it happens to be that if you get it wrong in the most common way, you still get it right. So I'll invite you to think about what students think 5 to the 0 is. I'm sure you have a prediction, but 5 to the 0 is equal to 1. If you didn't say 1, you know what most students get for 5 to the 0. 5 to the 0 is equal to 1. And that's smaller than 2, right? So the answer is not choice 3. The answer is choice 4. Número 15, number 15. The function f is graphed on the set of axes below. What is a possible factorization of this function? F of x equals x minus 1, x plus 3, f of x equals x plus 1, x minus 3, f of x equals x plus 1, x minus 4, or f of x equals x minus 1, x plus 4. Now, this is a great example of yet another one that students maybe don't remember how to do and forgot something that was done in class and skipped steps, etc., and still didn't get it. But then in the end, don't bother doing it on the calculator either. This one you could do on the calculator. Plug in values of x, see which one matches. In fact, it happens to be that if you just plug in the roots, that's enough information. But here's another point that you could plug in. Plugging in 0 is something that a lot of teachers don't recommend anymore because the test has been generated in such a way that plugging in 0 doesn't always work. But plugging in 0 eliminates a lot of choices. Plugging in 1 tends to eliminate a lot of choices. Now, if you plug in 0 and 1, you tend to really eliminate almost all the time, almost every choice. Not guaranteed, but it's a phenomenal piece of advice. It's not bad advice. So now we're left with 2 choices and 1 in 2 chance of getting it right on 24 questions. That is almost a passing grade. Then you literally have to know how to do 1 problem out of the remaining problems, or 2 technically, because the math is funky that way. How to do this algebraically? So you have to know what the roots are. So root x equals 1, negative 1. Let me break that a little more. Negative 1, and here you have a root x equals 3. If you look at these answers, with the roots of negative 1 and the root of 3, you could actually see, just based on the format of choice 1 and 2, why, if one of them is the correct answer, why the other one is usually the most commonly chosen incorrect answer. So, but notice here that if x is equal to negative 1 is a root, we need to know the factor. Well, that means that x plus 1 equals 0. X plus 1 is a factor, which makes this look good and this look bad. And same thing with x equals 3 is a 0, is a root. And so if x plus 3 is a root, if x equals 3 is a root, then x minus 3 equals 0. So x minus 3 is a factor. And that looks good again for this one and not for this one. And so choice 1 is definitely not the answer. Circle that, and there's our answer, okay? Número 16, number 16, the range of f of x equals x squared plus 2x minus 5 is the set of all real numbers less than or equal to negative 6, or greater than or equal to negative 6, or less than or equal to negative 1, or greater than or equal to negative 1. Now, I invite you to think about what you can say about this problem. You may not remember what the range means, but which is tough. I get it. But you do need to know domain and range, what they mean at least. Domain and range, notice that domain and range, DR, alphabetical order, X, Y, alphabetical order. Domain is the valid X values that can be plugged in. And range is the valid Y values that come out. So here's the thing. You can actually graph this parabola, okay, and see what the graph looks like, okay? If you get x squared plus 2x minus 5, okay? If I graph this, now my graph is weird because I have to do zoom standard. Let me do zoom standard when it's done graphing. Zoom standard, number 6. Now I see the parabola is an upward facing parabola, which I should have known because a, the coefficient of x squared, a is equal to 1, which is a positive number. So it's an upward facing parabola, which means that the graph is definitely above some negative number. So the range is actually greater than or equal to something, okay? So definitely not pointing down. The range is less than or equal to -6? No way. Or less than or equal to -1? No way. So now I'm down to 2 either greater than or equal to -6 or greater than or equal to -1. And in fact, the calculator does tell me that the range, here's -1, and I still got some points below -1. Okay, so the graph, the calculator does tell me, let me see if I can drag this over. Yep. The graph of the calculator does tell me that, in fact, the graph goes below -1 all the way down to -6. Okay, so the answer is not that. But how to do this in algebra, yet I'm priming you one more time to listen. This is the vertex, okay? And this is something that you do need to know. So how to get the x coordinate of the vertex is located at h equals -b over 2a, where this is in standard form. A is equal to 1, b is equal to 2, c is equal to -5. So h is equal to -2 over 2 times 1, which is -2 over 2, which is equal to -1. Now that might be where students get that -1 number from, but that's the value of h, that's the vertex. And so the y-coordinate of that vertex is k, which is equal to f of h, which is equal to -1 parentheses squared plus 2 times -1 plus minus 5, which is equal to 1 minus 2 minus 5, which I could do on the calculator. I don't have to put this on paper, but because I'm a math teacher, that's why I'm doing it this way. 1 minus 2 is -1 minus 5, to show you how I do it, -6. But of course, again, at this point over here, this is where I used to mark. At this point over here, or at this point over here, you could start putting it into the calculator, whichever one you want. And don't get it wrong just because you want to do it on paper. Be proud, you know? Again, like, don't resist the calculator when it makes sense. Don't not resist the calculator when it doesn't. So yeah, the vertex is at -1, -6. -1, -6. And so the range has to be everything above -6, y greater than or equal to -6. Número 17, number 17. The table of values for 4 functions are shown below. And I do a quick cursory glimpse at the tables, and then I read the rest of the problem because I'm going to go back and read it. You don't have to input 20 times 2, 40 numbers and remember them in your head. That's not possible for most. It's not possible for me. So there you go. We got x 1, 0, 1, 2, 3, 4. We got f of x 6, 7, 10, 15, 20. Okay, x 0 through 4 for all of them, in fact, and then h of x 1, 2, 4, 8, 16, or 0, -2, -2, 0, 4, or 2, 5, 8, 11, 14. Okay, so which table best represents an exponential function? Exponential function. Okay, f of x, g of x, h of x, or j of x. There's actually 2 types of functions. There's a lot of functions that I want you to be able to recognize, but there's actually 2 types of functions that I want you to recognize especially. And the fact is that if you can recognize these 2 types of functions in a table, you're mostly good enough, because the truth is you could actually almost always recognize the other ones too, just from starting from the first 2. So first, make sure to make your guess. Now I have to go back and start looking at the numbers. So all the x's are 0 through 1, 0, 1, 2, 3, 4, but now this x is 6, 7, 10, 15, 22, 0, -2, -2, 0, 4, 1, 2, 4, 8, 16, or 2, 5, 8, 11, 14. Now, it happens to be that one of the two tables that I want you to recognize, I want you to recognize, and actually I need to move this now. From tables, linear functions and exponential functions. From tables, okay? That's something I want for you right now as a student, because they're really very easy to verify. And the truth is that once you have those, one, you have most questions that they're going to ask for, because they often ask for linear, exponential, and maybe some others. So once you're done with linear and exponential, you've got most others. So how do you recognize a linear function? Well, notice that this is increasing by +1, +1, +1, +1. Now, same thing here, +1, and I chose these two specifically, +1, +1, because one of these is linear, the other one is exponential. Notice that J, this 2, 5, 8, 11, 14, if I try to do +3, +3, +3, +3, it's a constant increase. This is linear. That's what linear functions do. As x increases linearly, so does y. Okay, so this one is linear. They want an exponential function. So J is not exponential. Okay, and I could do that for F and G also, but neither of those are linear. But now, if I try to do the same thing here for H, I try to do +1. 1 + 1 is 2, but 2 + 2 is 4. 4 + 4 is 8. 8 + 8 is 16. This is not linear, right? This is not linear, okay? Because it's not increasing by adding a constant amount. However, I notice that if I do, instead of plus, I do times 2, that's the second one, exponential. 2 times 2, I'm multiplying by a constant amount. Times 2, 8 times 2 is 16. So remember, I'm not looking at that anymore. 8 times 2 times 2 times 2 times 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I'm multiplying by 2. That's exponential. So linear functions increase by a constant sum. Exponential functions increase by a constant multiple, okay? So these increase by a constant sum, and exponentials increase or decrease. Oh, actually, I really misspoke. Increase or decrease by a constant sum, and exponentials increase or decrease by a constant multiple. And so H is definitely exponential. And since they asked for exponential, it's choice 3. That's it. And you could check to see if F and G do that. And look, it's a little bit of work. Like, you do have to check if linear properties are satisfied or exponential properties are satisfied. But it's an algebra test. Like, you saw all this work that I did. Do you know how many of these problems I see that are just totally blank because students just don't want to do the work? Or they train themselves not to do the work because the teacher doesn't do it. And then they end up just not doing anything. And of course you don't know how to do this visually. Of course you don't. But if you look for that, you actually do the algebra, do the arithmetic. Remember I said, write down everything I said. You will get this question right if you recognize linear and exponential functions. Algebra 1 tends to not go very far beyond that. Now, it does happen to be F is quadratic and G is also quadratic. Número 18, number 18. If f of x equals x squared minus 3x, then which statement is true? F of 1 equals f of negative 1, f of 2 equals f of negative 2, f of 1 equals f of 2, or f of 1, a negative 1 equals f of negative 2. And I mean, if there's ever any problem that you could do by plugging in, literally, this is the only real sensible way of doing this problem. They're literally just asking you to plug in numbers. But I will say this, that students who don't do this on the calculator when they should get it wrong anyway, and students that refuse to do some part of it because they like skipping steps will get it wrong often. Choice 1 and choice 2 are really common incorrect answers. But it happens to be, and this is a good thing, that choice 1 and choice 2 are common incorrect answers because of the same reason. So if you don't know how to do one of them, chances are you'll realize that they both can't be right because it is a multiple choice test. So if they can't both be right, something went wrong. But again, I'm gonna simulate only plugging in x equals 1 into the calculator. Okay, and I could do this by table. Press y equals. And that's actually the way that I would advise you to do it most of the time. But since this one is such a simple thing to plug in, I'm actually gonna just do it manually. Negative 1, close parentheses squared. Again, this is an extremely common source of error. If you just kind of always put a parentheses around your negative numbers, you'll always get the question right. So if you're afraid of using, if you don't remember if you need to put parentheses around negative numbers, but you just always do, you'll get the question right because you're always allowed to put parentheses around your negative numbers. Always, 100% of the time. Now, the thing is that if you do negative 1 squared without parentheses, you're going to get it wrong. Okay? Plus 3 times negative 1. And you get negative 2. So you get 4 and negative 2, which are definitely not equal to each other. You get already, this one's already done, 4 and negative 2. So we've already eliminated one choice. And we've also done half the work for the other problems. Might as well choose 2 or negative 2, which is convenient because we'll be able to confirm this one as well. So let's plug in x equals 2. Well, x equals 2 is going to be too big. Okay? Actually, so we don't even need to plug this one in because right now, but we're going to plug in x equals negative 2 into the calculator. And again, on paper, f of negative 2 is equal to parentheses negative 2, close parentheses squared, plus 3 times negative 2. And that is equal to negative 2 squared is 4. 4 plus negative 6 is equal to negative 2. And this is actually equal to negative 2. Okay? So f of 2 is big, and this is equal to negative 2. This is positive. A positive number can't be negative 2. Okay? So that is nice process of elimination. The answer is choice 4. Okay? So, look, this was more advice than algebra here. But take my advice. There's so much process of elimination here that I didn't even get to mention. Like for the fact that if you plug in, all the coefficients are positive, so you plug in a positive number for x, you're going to get a positive number. That actually eliminates choice 2. If you plug in x equals negative 1, it eliminates choice 1. And the fact that if you plug in x equals 2, you get a much bigger positive number, it eliminates choice 3. And you're really only left with one choice. Lots of process of elimination. So I just eliminated all the choices. Some things will eliminate some of the choices, but there's always something for every problem that can be done to eliminate some of the choices. All right. Number 19, numero 19. Jack started a new fitness program. By the way, I said it before. The longer worded problems, a lot of times students skip them because they're harder. But I want you to understand, and I hope that this is a recursive sequence problem, so I know a lot of students struggle with the concept. But with long worded problems, the long worded problems actually tend to be easier. Now, this is a number 19, so it's also further along in the test, so it could be a little bit harder as well. But again, don't skip the long worded problems just because they're longer. They might actually be easier, generally speaking. Jack, number 19, número 19, Jack started a new fitness program. The first day, he did 10 push-ups. I'm doing a fitness challenge with push-ups right now. The program required him to, okay, so let me just read it without. Jack started a new fitness program. The first day he did 10 push-ups. So you're imagining you're Jack, you're doing 10 push-ups. The program required him to increase the number of push-ups each day by doing 9 less than twice the number of push-ups from the previous day. Which recursive formula correctly models Jack's new program where n is the number of days and an is the number of push-ups on the nth day? So n equals the day. A sub n is equal to the number of push-ups on the nth day. Okay, so I know that the first one has to be equal to 10. So A1 has to be equal to 10. That's satisfied there, that's satisfied there, that's satisfied there. Actually, they all have A1 equals to 10. So unfortunately, we can't eliminate that way. Now, it does help to know what recursive means, but let's see. So an equals 2a sub n minus 1 minus 9, or a sub n equals 9 minus 2 times a sub n minus 1, or a sub n equals 2 times n minus 1 minus 9, or a sub n equals 9 minus 2 parentheses n minus 1. Now use your process of elimination. This is going to be an example where I'm going to give you both things that I think are wrong based on the wording of the problem, but I'm also going to verify things that I know are wrong based on the wording of the problem. Let me just see where it says recursive. That's going to be the thing that allows me to say what I know is wrong. Here, it says 9 less than twice the number of push-ups on the previous day. 9 less than twice the number of push-ups, okay, from the previous day. Okay, so I see 9 less than twice. I see twice n minus 1, but n is not the number of push-ups. N is the day. So n minus 1 is the previous day, just the actual day, not the number of push-ups from the previous day. So I suspect that this one is wrong, and I suspect that this one is wrong. Notice I put the x next to the answer, not on the answer, because I'm only suspecting that it's incorrect. Now, I told you that I would actually do a process of elimination to eliminate all incorrect, to eliminate incorrect answers sometimes, for every problem. Now, the fact is that if you happen to know what a recursive formula is, again, a recursive formula requires you to know the previous day's value. Okay, so the recursive formula, it uses the previous values of an minus 1 or earlier to get an. And then explicit formula uses only n to n numbers to get a sub n. Okay? Uses only n and other numbers to get a sub n. So notice that choice 3 and choice 4 do not use a sub n minus 1 nor any other value of a to get a sub n. So choice 3 and 4 are actually incorrect because they're not even recursive. Yeah. Okay. So that's wrong. Okay. So now we're left with choice 1 or choice 2, and we could go to the words. The program required to increase the number of push-ups each day by doing 9 less than twice the number from the previous day. So this is where I go and I say, today, push-ups, this is the word equation that I recommend, right? Is 9 less than, and I remember that 9 less than is going to be something minus 9 later. 9 less than twice, 2 times the yesterday's push-ups. Okay. So today's push-ups, which is a sub n, according to them, right? A sub n is the number of push-ups on the nth day. That means that A sub n minus 1 is yesterday's push-ups. So 9 less than something means I'm reducing something by 9. That means that the minus 9 is going to go at the end. Now twice yesterday's push-ups, 2 times yesterday's push-ups. If A sub n is today's push-ups and yesterday is n minus 1, then that yesterday's push-ups is A sub n minus 1. Where is that? 2 parentheses A sub n minus 1 minus 9. Here it is without parentheses. It didn't require the parentheses, but so I got the answer, and it's not this one. This one is the incorrect subtraction order. I didn't mean to put the X on there because I didn't do that by process of elimination. That's just my notation. Yeah, the X means I eliminated it by correct math process of elimination. Okay, yeah. And look, this is not even the first time that the incorrect subtraction order caused us to eliminate an answer. That is a common thing. So if you just remember, 9 less than something means I'm subtracting 9 later. 2 less than something means I'm subtracting 2 later. 17 less than something means I'm subtracting 17 later. That's points. That's points on the regents, just that one fact. I just did you a favor. Numero 20, number 20, which equation is equivalent to x squared minus 6x plus 4 equals 0? X minus 3 squared equals -4, x minus 3 squared equals 5, x minus 3 squared equals 6, or x minus 3 squared equals 9. Now, I've been priming you to pay attention to how I do the problem algebraically. Even if I get the answer in a non-algebraic way, and I've been priming you to do it, and I've been hinting at you that there's some point where you might want to pay attention. So I'm going to do this problem on the calculator so that you could see how to do it on the calculator. But then I'm going to do it algebraically, and I really want you to pay attention on how I do it on the calculator. How many hats do I have up there? Still have 2. Okay. So, so how am I going to do this on the calculator? Here, I'm gonna actually go to y, and I'm gonna put this expression. I got x squared. I need to delete something here. Okay. Minus 6x plus 4, okay, equals 0, okay? Now I go to the table, and I could hope that I have my zeros on the table, and I don't, okay? And I don't. But if I graph it, though, okay? If I graph it, I see that there's zeros. So I see a 0 that's really close to 1, and I see 2, 3, 4, 5. It's slightly bigger than 5 also. There's another 0. But I can get the 0 from the calculator. And you see above, the graph button to the left is trace, and then above trace is calc. It can calculate the 0. Calc is in blue, so I could press second calc. And I'm going to calculate the zeros. Choice 2, 0. Now I go to the left of one of the zeros, and I go to the right of one of the zeros. And then it says guess. So I'm going to actually bring that over here. Now remember, they don't care about seeing the calculator screen because they just want your answer. So you don't have to be able to drag your screen over. Same thing, I'm going to get the other 0. So calc is in blue, so I press the blue second button and then calc. And then I get the 0. I'm going to go to the left of that second 0, slightly to the left of it, and now slightly to the right of it. Now I can guess if I want, but I'm actually just going to press enter, and I get this 0. X is around 5.23. Okay. So I got my zeros there. Okay. Now you may wonder how I can use these to confirm which answer is correct. Okay. But the way I could do that is by finding out which of these equations satisfies that same condition. If you notice that all of these are, all the choices are x minus 3 squared equals a number. I'm going to call it J for JuanTutors. Subtract J, and I got x minus 3 squared minus j, whatever j is, -4, 5, or 6, or 9, I get that that's equal to 0. So this equation has to be equivalent to the original, so it has to have the same 0. So there we go. So that's what I'm going to do. I'm going to check which one of these has the same 0. And all I have to do is subtract 9 from each one, or 9, or 6, or 5, or -4. And I could do this either here, or I could do it here. And in this case, I'm going to do it on this screen just so you see. I'm going to plug in 0.76393202 minus 3 squared. Now, if I'm going to guess at one, I'm just going to go from the ones that I know I can't mess up. I know I can't mess up subtracting 9, but I got to get 0 or close to 0. That's -3.99, etc. That's not 0. How about if I did the same thing? I could highlight that and press enter again so it types it for me. How about if I subtracted 6? Now I got -0.99. Oh, now I'm getting closer. How about if I subtracted 5? I get a number 1e -8. Now, this is something that you need to know about. The calculator, if I put in a decimal here, the answer might be just extremely, extremely close to 0, so the calculator tells you that. But usually that happens when there's an approximation. The e -8 means times 10 to the -8, which is an extremely small number. This means 0.000000001 at 1813, okay? Or something like that. I think I used too many ones. But the point 0.000, etc., that's extremely close to the answer is 0. So the answer is not choice 4, not choice 3, definitely choice 2. And if you want to just confirm that the answer is not subtracting -4, minus -4, I don't get a 0, right? I get a positive number, in fact. So that's definitely not the answer, okay? Now, I said that I would reward you for paying attention to the algebra. So if you want, you can go ahead and skip to number 21. Go ahead and skip to number 21. But now I'm going to show you how to do the algebra on paper. But I will also tell you this. Did you know that a lot of students, when they're, and I see this because I see the viewership of the videos, do you know that a lot of the students don't bother watching me do the algebra? Once I just give the answer, they don't bother doing the algebra. So to reward you, if you're still watching this is a reward, not a punishment for the people who decide not to watch me do the algebra, because you know what? They do what they do for themselves, whatever they think is right. Who knows if they're 30 minutes from the test and they want to watch the rest. But to reward you for continuing watching this, I'm going to do a quick hat change. And I said that the hat change is relevant, and I'm going to tell you why in a second. Notice this, I did a hat change, but I didn't put the hat there. To reward you for knowing that this is the 4th hat that I put on, but there's only 2 up there. 2 plus 1 is 3. So that's for you. I promise it's gonna be mentioned later on in the video. So what happens is a lot of students just don't bother watching the algebra. Let's actually do the algebra. So this is a completing the square, which is a relevant skill for Algebra 1, for a bit geometry, definitely Algebra 2, and definitely pre-calc and calculus. So we're going to actually do this problem by completing the square. So if you have x squared minus 6x plus 4 is equal to 0, this is in standard form, and this is by completing the square. All of these are completing the square. Okay. So what we do is first we make sure that a is equal to 1, and it is. If a is not equal to 1, we can divide by a. And it makes the arithmetic a little bit tougher sometimes, but we just divide by a. So we make sure a is equal to 1. Then we subtract, if it's not equal to 1, divide by a. Okay? so but A is equal to 1, subtract 4, so subtract C, okay? And you get x squared minus 6x is equal to negative 4, okay? And then step 3, again, I wish I could explain why we do this, and it's not, but the reason we do this is because the left side is not a perfect square. It's not. So we're completing the square to make it a perfect square. So you write this, b equals negative 6. Okay, you write b over 2 equals, well, negative 6 over 2, which is equal to negative 3. And then you write parentheses b over 2 squared, which is equal to negative 3 squared, which is why you need the parentheses around the negative numbers. A lot of students will say like negative 9, but it's not 9. Negative 3 squared is positive 9. Step 4, you add b over 2 squared to both sides. Okay? And why do we do that? Plus 9, plus 9. So you have that x squared minus 6x plus 9 is equal to 5. Why do we do that? Because now the left side is a perfect square. Now step 5 is we factor as a perfect square. And using b over 2. Using b over 2. So this b over 2 is negative 3. The left side is parentheses x minus 3 squared is equal to 5. And there's our answer. And that's a powerful tool. It doesn't feel like a powerful tool, but notice the left side is a perfect square. It's the quantity x minus 3 squared. It doesn't feel necessarily like a powerful tool, but the original problem had a we would have to had an x and an x squared. You can't combine like terms to solve it. Because by the inverse operation method, at least you could do the quadratic formula. There are other options, but this one, now x appears exactly once. You could actually solve it by the inverse operation method. Take the square root of both sides. You get x minus 3 equals plus or minus 5, and add 3 to both sides, and you get x equals 3 plus or minus radical 5. And so it's powerful, and it's powerful in geometry. It's powerful in algebra 2. It's super powerful in calculus, believe it or not. Okay, and now notice what I said. Don't forget what I said earlier about stuff, right? It's about something. I said something interesting at the end of problem 20, and those of you who watched me say it got a little bit of a reward, a hint of some sort. Number 21, numero 21. What is the equation of the line that passes through the point 6, negative 3 and has a slope of negative 4/3? Is it 3y equals negative 4x plus 15? Is it 3y equals negative 4x plus 6? Or is it 3y equals 4x plus 15? Or is it negative 3y equals 4x plus 6? Well, it's an interesting way of writing the equations. I don't know why they might write it that way, but maybe because it's a problem 21 later in the problem that you need to do some algebra. But same thing as many of the problems, you could actually do this by process of elimination by, if you get lucky, maybe none of the choices satisfy this point, but plug in the point and see which of the equations satisfy it. For example, I'm gonna randomly, I'm not gonna say which one of these I actually tested. I'm gonna use my random number generator. I'm gonna test choice 3. I'm gonna plug in 6, negative 3. X is 6 and y is negative 3. Okay, so I got negative 3 parentheses negative 3 is equal to 4 times 6 plus 15. This is entirely too big on the right. 9 is equal to 24 plus 15. So 9 is equal to 39. Ew. So that's not it. In fact, just by plugging that in, I can confirm that this one's not correct either. Because 24 plus a positive number is still not going to be 9, no matter what universe you live in. So it's either choice 1 or choice 2. By plugging into 1, I confirmed that 2 were incorrect. 2 birds, 1 stone, all gone. So looking at the form of this, by the way, plugging in will also confirm which of these is incorrect. Okay, so if you decide not to plug in, tough for you, you could get this problem just by plugging in. Okay, and if you don't know how to do it on a paper, like for example, a lot of students get -3 times -3 wrong, but you have a calculator. So if you're the kind of student who gets -3 times -3 wrong, use your calculator, and you win. How do I do this algebraically though? I'm not going to do the last plug-in for you because you could just do it. How do you get this? Goes through the points 6, -3, and has a slope of -4/3. So the point slope form with m equals the slope, and x1, y1 is equal to a point. The point slope form of a line is y minus y1 is equal to m parentheses x minus x1. Okay, so you get the slope is equal to -4/3, and the point is equal to 6, -3. So you get y minus, you do have to know that the order of the numbers, y minus -3, okay, equals, there's nothing that makes a negative sign disappear. Remember, know what you don't know. There is, know what you, that includes knowing that, like, is there something that makes negative signs disappear? No. Lots of students just, there's 2 negative signs, so they would just write one of them because one of them disappears. No, it doesn't. Never, never. -4/3, parentheses, x minus 6. Distribute the -4/3. You get y minus -3. You could do +3 now, equals -4/3 x minus negative, so plus, you could do on your calculator -4 divided by 3 times 6, and you get plus 8. And then subtract 3, and I get that. Let me bring this over here for you. Y equals -4/3 x plus 8 minus 3 is 5. And now this one has a 3y for some reason, but if I multiply everything by 3, I distribute in, I get 3y is equal to -4x plus 5 times 3 is 15. How many hats do I have up there? Okay. Told you it was relevant. I proved it already. Number 22, numero 22. The function g of m represents, well, I do got to check the time because I got to go to a party. The function g of m represents the amount of gasoline consumed by a car traveling m miles. An appropriate domain for this function would be one, the integers or the rational numbers, or the non-negative integers or the non-negative rational numbers. So now this is an interesting question. You might debate which one is an appropriate domain. I don't like the choices philosophically speaking because I like another answer, but based on the ones that are here, I know that there's a big hint. There's some of them say non-negative and some of them don't, right? And then also some of them say integers and some of them say rational numbers. So that's the difference between them, right? It's kind of a binary, it's a 2x2 question. I like these 2x2 questions, which we've saw a lot of them. But 2x2 means that you could eliminate them, you could eliminate some of the choices in 2 different ways. And in fact, if you could eliminate the choices from non-negative versus not non-negative and separately from integers versus rational, you got your answer. And that's actually how to do this problem. We're driving. So the domain of this function, we don't gain gas by going backwards, right? The car just spends gas. So the integers go negative. -1, -2, -3. The rational numbers go negative. -1, -2, -3 also, or -0.5. You don't gain gas by going backwards. So having the integer and the rational numbers be part of the domain doesn't make sense because they include negative numbers. So it has to be non-negative integers or non-negative rational numbers. So what about whether it's the integers or the rational numbers? The integers, and the symbol for the integers is this interesting looking Z. is equal to negative 11, negative 10, negative 9, negative 8, dot, 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 negative 2, negative 1, negative 0, negative 1. Oh, dot, dot, dot on this side also. 0, 1, 2, dot, 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 8, 9, 10, 11, 12, 13, dot, dot, dot. Or in other words, equal to the plus or minus the whole numbers. Okay? And then, of course, the rationals is equal to, and it's the interesting Q for a quotient, by the way, that's why Q comes in, is equal to A over B such that A and B are integers. And also you can't divide by 0. And it's also equal to the repeating pattern or terminating decimals, but that doesn't matter right now. But the point is here, can we drive 2/3 of a mile? Yeah. A mile is actually a pretty long distance. You actually often measure miles in fractional amounts or even decimal amounts. My car measures it in tenths, like I'm 2.3 miles away. Yeah. So the rational numbers is the one that makes the most sense. Okay. So it's not, the non-negative integers is not the appropriate domain. Numero 23, number 23. The table below, and we're almost done with the multiple choices. This is exciting. The table below shows the number of reported polio cases in Nigeria from 2006 to 2015. That's an exciting number. Congrats to Nigeria and to everyone who made that effort. But I look for I look at the table cursorily. Year 2006 to 2015. Number of cases 1129 down to 0. What is the average rate of change to the nearest hundredth of the number of reported polio cases in Nigeria per year in Nigeria from 2006 to 2013? But we need this one, okay, and this one, okay. Is the rate of change negative 0.01 or negative 125.44 or negative 134.50 or negative 153.7? So the average rate of change of the number of reported polio cases, so we have to look, the number of polio cases went from 1,129 to 53. That's a big change from 2006 to 2013. So the rate of change has to be much bigger than 1. That eliminates choice 1. Now, from negative 125 to negative 134 to negative 153 and change, I don't personally have any intuition on it, but I do see that the number of years is 7. So if I do a quick estimate, like if I just say, well, 7 is less than 10, so the rate of change is definitely 1129, is faster than a negative 1129 over 10, which is negative 112. I have a feeling that negative 125 is just too close to negative 112 for it to be the answer. So, but look where I put the X. Okay. I put it next to it because I'm not 100% sure. Okay. But even if I'm not sure how to do average rate of change, I'm in a much better place. Now, the average rate of change, I do need to know the formula. Is equal to y2 minus y1 over x2 minus x1. And so then the y2 is the final. I could do, again, y final minus y initial over x final minus x initial. Either way, that's just symbolic notation. So 53 minus 1129 over 2013 minus 2007. Oh, 6. Okay. And now this is a calculator problem. And a lot of students get this question wrong by just not putting into the calculator. And this is literally, one of these things is that this is checking is whether you put it into the calculator correctly. Okay. So let's do the numerator. 53 minus 1129 is negative 1076. And then some students just don't do this arithmetic on paper, or they just make weird assumptions about what the number should be. But the difference is 7. Okay, and if you said a different number, I mean, you probably should have just done it on the calculator. So negative 1076 over 7 is negative 153.71 and change. Okay, so that's how to do the problem. And process of elimination eliminated one that's definitely wrong, and an estimate that was an estimate. In other words, correct math, which made a likely answer wrong. I'll answer likely wrong. Some of those estimates can actually confirm that an answer is wrong, and I will see if I don't think it's going to come up now, but it does come up in a lot of multiple choices. In a lot of part 2, 3s, and 4, you make an estimate so that your estimate confirms whether your answer makes sense or not. I highly recommend making estimates. Joe compared gas prices in England and New York State one day. In England, gas sold for 135 euros per liter, and $1 equaled 0.622 euros. A correct way to figure out this cost in dollars per gallon is one of these. I'm not going to read them all before anything, but I would say if you're doing this problem, look at where the units are and see if they cancel correctly. That's all. That's fully will get you the answer from step 1. For process, so it's either the first one, the second one, the third one, or the fourth one. I will say this: I noticed that the second one has liters in the denominator twice, so liters is not going to cancel. So can't be choice 2. The third one has euros in the numerator twice. Euros won't cancel. So that can't be the answer. And this one has euros in the numerator twice and liters in the denominator twice. So neither euros nor liters will cancel. And there's my answer. Look at that. Lovely. But the point of this is, and this is a heavy chemistry problem, but they do this in the part 2s, 3s, and 4s also in this test in Algebra 2. The point is that this is conversion factor math. So you have to convert euros per liter, 1.35 euros per liter. Now, how do you convert this into dollars per gallon? You have to cancel euros and leave behind dollars. And you also have to cancel liters and leave behind gallons. So to cancel euros in the numerator, and units do cancel because that is a multiplication. It's the number 135 times the unit euro. Units do cancel with arithmetic. So I have to cancel euros with dollars. To cancel euros, I have to have euro in the denominator, which means I have to have dollars in the numerator. And this says $1 is equal to 0.622 euros. $1 is 0.622 euros. And then I also have to cancel liters by putting liters. Liters was in the denominator, so I have to put liters in the numerator to cancel it. And I have to be left with gallons. So gallons is going to be left in the denominator. So that'll cancel liters. And let's see, it said, I want to point out here, actually, great thing to point out, the conversion between liters and gallons isn't here, right? But we took a tour of the formula sheet, the regents, and the formula sheet in the back. There is a conversion between liters and gallons. So there's 2 of them, okay? 1 gallon equals 3. I'm going to take a screenshot here. And either one of these put in here will get you the right answer. But of course, because it's a multiple choice, you don't, whichever they put in is the one they use. They use that 1 liter is 0.624 gallons. And if you see that here, 1 liter is 0.264 gallons. And they could have used the other one, but they didn't. So either way, the answer is this. Okay? All right. Now we're at the part 2s. And we are reading the instructions for this one. But remember, this, that it's going to say need not be drawn to scale type of thing, but if you need to, assume it. And this problem specifically, number 25, is golden, because even if you don't know how to do the problem, but you remember what a rational number is and you use your calculator, you can actually get 1 point out of 2. This one, answer all 8 questions in this part. Each correct answer will receive 2 credits, but it has to be completely correct. Clearly indicate the necessary steps, including appropriate formula substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that the diagrams are not necessarily drawn to scale for all, but remember what we said. If they're not drawn to scale, but you have no clue how to do it, assume it's drawn to scale. A better strategy, by the way, is to check if it's drawn to scale. Okay. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. Look at that. Correct answer, numerical with no work, will receive a credit. So if you happen to know how to do it on the calculator, give the answer on the calculator. They tell you that a correct numerical answer will receive 1 credit. Points. Do it. Calculator. That's a gift. And remember, 1 point doesn't feel like a lot, except 1 point is half a multiple choice question. So if you're talking about the strategy focusing on the multiple choice, which I don't recommend, but if you're talking about the strategy, focus on the multiple choice, well, this is focusing on the multiple choice by using your calculator and eking out every single problem. Because this is fake logic, but if you use the part 2s to gain points, you're using the multiple choice by not requiring so many of them correct. So if you just get points on the part 2s, 3s, and 4s, you're in a better place. Also, if you get points on the part 2s, 3s, and 4s, your grade just starts blowing up, which is great. So classify the expression 2 over radical 144 plus stupid COVID. As I was saying, I just got over COVID like a week and a half ago, but I'm still struggling. Look, get your vaccines. Forget all those people who are afraid of the vaccine. Just go get it. Number 25, numero 25. Classify the expression 2 over radical 144 plus radical 169 over 3 as rational or irrational. Explain your reasoning. They allow this. Put it in your calculator, and then evaluate, and then say what it's equal, and based on what it's equal, 2 over radical 144, enter, plus radical 169, that over 3, 4.5. So if you just put 4.5 and then say rational because it's a terminating decimal, you got the answer. But I'm gonna do it. It just happens to be that this simplifies. 2 over 12 plus 13 over 3 equals 4.5. Okay. There's my work showing a little bit of work. Okay, and then I could say rational because it is a terminating decimal. So just a quick review again, the rationals is equal to the set A over B such that A and B are integers, and B is not equal to 0. Okay, let me move this down a little bit. Okay, but it's also equal to X such that X is a terminating or repeating pattern decimal. So in other words, it has to be a terminating or repeating pattern decimal. It can't be just any pattern. Plenty of decimals don't have patterns. Pi doesn't have any patterns at all. But and the number E doesn't have any patterns at all. But you know, some decimals have patterns. 0.1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. See, now I'm increasing the number of zeros. That is not a repeating pattern. That is an increasing number of zeros pattern. A repeating pattern would be like 0.253, 253, 253, 253, 253. Or it could start weird as long as it becomes a repeating pattern, like 8.75, 9-1, 9-1, 9-1, 9-1, 9-1, and it doesn't deviate from 9-1, 9-1, 9-1. That's a repeating pattern decimal. Or it could be 4.5, just ends, terminating decimal. All of those are rational. These are the same set. Terminating or repeating pattern decimal, or the fractions are the set of rational numbers. Okay? Full credit right there. Now, if you just said 4.5, I think that's a point. If you had said rational, that's a point. If you had said 4.5 and just the 4.5 and rational because it's a terminating decimal, 2 points, which is worth a full multiple choice question. And congrats if you got those points. Number 26, and I want to point out there's an empty box, 12 things in this empty box, okay? But it turns out there's not so many degrees of freedom in the empty boxes. So you could actually do this problem pretty nicely. So Julia surveyed 150 of her classmates at City Middle School to determine their favorite animals. Of the 150 students, 46% were male. Hold on, I gotta read the table real quick because that's actually what I do. I read the headings of the table and then I go back to the problem. Horse, dolphin, penguin total, male and female total. So this box is probably gonna be total. Okay, cool. So now back, Julia surveyed 150 of her classmates at City Middle School to determine their favorite animals. Of the 150 students, 46% were male. 42 students said their favorite animals was a horse, and 1/3 of those students were female. Of the 60 students who said dolphins were her favorite animal, 30% were male. Use this information, complete the two-way frequency table below. Now, I want to point something out here again. There's 12 empty boxes here, so you might be like, wait, 12 empty boxes from this little bit of information. I can't do this problem at all. First off, you can get partial credit. Okay? So that's first. It's worth your time. Even if you get a little thing wrong, you get partial credit. The second thing you need to point out, the headings, horse, dolphin, penguin total, male, female total, and then total on total here. Oh, that's a lot of total. Okay, but the point is there's 12 empty boxes here. But that doesn't mean that there's 12 variables or 12 degrees of freedom here. Because you see this total here has to be, let me get a little highlighting going on here. These three numbers have to add up to this. That's 1 degree of freedom down. These three numbers have to add up to this. These two numbers have to add up to this. These two numbers have to add up to this. These two numbers have to add up to this. And then these have to add up to this. And these also have to add up to this. And also the 6 separated things have to add up to this. Now that's 3 equations, but that's actually still just 1 degree of freedom because of all the relationships. So there's only 6 degrees of freedom in the problem, which by the way means that for you to be able to fill out this table, they have to have given you in this information 6 pieces of information. And that's it. That's all they have to give you, 6 pieces of information. Somewhere in these words, they give you 6 pieces of information. If you use those pieces of information to get some of the numbers, you get partial credit. Now check this out. That's exactly what we're going to do here. So we're going to go slowly plotting. Let's see. It says Julia surveyed 150 of her classmates. This is the total at City Middle School. Here's the 150. I already got a number. To determine their favorite animals. Of the 150 students, 46% were male. Okay. So 46% of the 150 students were male. So the total female and the total male can be determined. 46% of the students are male. So 0.46 times the total, 150, is equal to, well, close to 75, right? Because it's close to half, but less. Because there's 6 degrees of freedom in these 12 numbers, we could use all the degrees of freedom to make sure they all match. 0.46 times 150 is equal to 69 male students. 69. Well, that means, well, that was interesting. That was a 9, not a arrow. Okay? That means that the number of female students is equal to 150 minus 69, which is equal to 81, according to my calculator, which I did put into my calculator just to be sure. We got 3 of the numbers already. That, believe it or not, is actually already worth 1 point. I could do nothing else, and I got a point. 42 students, that's the number 42, said that their favorite animal was a horse. That's the total down here. 42 said their favorite animal was a horse, and 1/3 of those students said that their favorite animal. I'm sorry. 42 said their favorite animal was a horse, and 1/3 of those 42 students were female. So 1/3 of the 42 horse lovers is equal to female horse lovers. So according to my calculator, 1/3 of 42 is 14. Is equal to the female horse lovers. 14. So the male horse lovers, so now that's another piece of information. Now we do have to finish the table to get the final set of points. The male horse lovers, well, then that's equal to the total horse lovers, 42, minus the female horse lovers, which is equal to 28. We're doing great so far. So it's not so bad. So I would invite you to just try to fill out the rest of the table. Remember I said do the problem on your own. This is one problem where it's just a fun puzzle. Treat it as a fun puzzle, because that's actually what it is. It's a logic puzzle. Of the 60 students who said dolphin was their favorite animal, so 60 students said that their dolphin was their favorite animal. We got to put that number in right away. 60 students said that dolphin was favorite animals. 30% were male. So 0.30 of the dolphins lovers are equal to male dolphin lovers. So 0.30 of the 60 is equal to the male dolphin lovers, and 0.30 of the 60 is equal to 18, according to my calculator. Put it in the calculator. 0.3 times 60 is 18. Male dolphin lovers. And now the female dolphin lovers equals the dolphin lovers minus the male dolphin lovers, which is equal to 60 minus 18, which is equal to 42. And actually, we already have enough information to fill out the rest of the table, because now we can go across. So the number of penguin lovers, so 42 plus 60 plus penguin lovers is equal to 150. So I'm going to subtract 42, subtract 60, subtract 42, subtract 60. We get the penguin lovers is equal to 48. Okay? And we can go across also. The same way, we can get the female penguin lovers, and then we could check our answer. So we go across on the female line. 14 plus 42 plus female penguin lovers is equal to 81. So we subtract 14, subtract 42, subtract 14, subtract 42 on the calculator, and we get the female penguin lovers is equal to 25. And I'm using a calculator this whole time. I'm not going to simulate pulling out your calculator every single time. Okay. And then finally, the male penguin lovers. So 28. Well, that was interesting. Don't know how that happened. Male. So 28. 28 plus 18 plus the male penguin lovers is equal to 69. So subtract 28, subtract 18, subtract 28, subtract 18, and you got the male penguin lovers is equal to 23. And we could check our answers now. Well, 28 plus 18 plus 23 is 69. 14 plus 42 plus 25 is 81. 42 plus 60 plus 48 is 150. Going downward, 28 plus 14 is 42. 18 plus 42 is 60. 23 plus 25 is 48. And 69 plus 81 is 150. 2 points. And in fact, we could have gotten 1 point pretty early on. Like, it really doesn't take much to get a point. If you say 150 for the total, if you said 42 students for the favorite animal was a horse, and if you said 60 favorite animal was a dolphin, and you give one more number, that's a point. That's a lot, you know? And a lot of this could be done in a different order than I did it. All right, número 27, number 27. Brian said that the piecewise function graph below has a domain of all real numbers. Now, it doesn't look like it does, but he said it. State 2 reasons why Brian's incorrect. So Brian is definitely incorrect. Why doesn't it look like to me? But I know the domain. It does help to know what domain and range are again. Domain is the valid x values that can be plugged in. So if you look for an x value and check if it's on the graph, then it's a valid x value. And the range is the set of valid y values that are hit by an x value that have a corresponding input in the domain. So the valid domain values are valid x values. Now, I'll tell you why a lot of students might get it wrong. They might notice that there's nothing graphed above, -4 and below. But the thing is that this is an arrow. You do need to know that the arrow means that it does continue. So for values of x below -4, this function does continue. But I do notice that at x equals 3, we have an open circle and an open circle. No closed circles. First reason is that the function is not defined at x equals 3. That's one reason right there. That's a point. Boom. You see that? Like, if you just see that, you're done. Okay? With a point, half a multiple choice question right there for you. So focus on the part 2s, 3s, and 4s just as much as you do with the part 1s. And notice that you have to do work on the part 2s, 3s, and 4s. The reason for teachers, why I tell them, don't tell them to focus on just the part 1s or the multiple choice, because students do the multiple choice but don't do any work for the multiple choice. Because we've trained them to not do any work for the part 2s, 3s, and 4s, and then they think they don't have to do work for the part 1s. How do you get a question correct? They're just spinning their wheels trying to figure out how to guess better. That doesn't make sense. You have to do the algebra to do well, and to guarantee a passing grade. Number 2, another reason, if I keep going past 3 to x equals 4, well, the function is defined at x equals 4, but there's nothing else graphed anywhere here, okay? So the function is not defined for x greater than 4. And there's my 2 points. If you notice any one of those 2 things, you get a point. If you notice both of those things, then you get 2 points. And a lot of you, even if you struggle, a lot of you can get that. So that's why, that's why you should do it that way. Okay, so this one, a lot of students get this one wrong, but the truth is that this one allows for a lot of partial credit. So if you make 1 algebraic mistake, you lose a point. If you make 2 algebraic mistakes, you lose 2. Okay, but if you just finish it and get 1 because you only made 1 mistake, great. Here's a weird strategy point, which I don't recommend. Here's a weird strategy point, though. If you purposely make 1 algebraic mistake, but it has to be an algebraic mistake, but also which happens to also allow you to solve the problem, you get a point if you do everything else right. Not a good strategy to purposely get something wrong, but if you do it that way, in a way that allows you to solve it, well, the 1 algebraic mistake got you the point. You know what I'm saying? Like, got you 1 point. Like, I'm like, that's good test taking strategy. I don't believe in teaching to the test, because teaching to the test is just how to get points. But at the same time, you're taking the test. You are taking the test, and and it goes on your transcript. So do what you got to do to get your points. You know. Okay. So this one says the formula D equals T parentheses VI plus VF over 2 is used to calculate the distance covered by an object in a given period of time T. Solve the formula for VF, the final velocity, in terms of D, T, and VI, the initial velocity. So, yeah, a lot of students don't bother with this one, but one algebraic error and you're done. If you happen to make only one algebraic error, then you get most of your points. There's no way you don't know how to start, you know? D equals T, because you could just make something up. You know what plus, minus, times, and divide is. You may say you don't know how to start, but what you really mean is that you don't know how to start in a way that you're 100% sure is correct. But again, know what you know and know what you don't know. Because the truth is, you might not know how to start, but there are a lot of things that you know you can't do, right? Like this T is not being added, so don't subtract. Don't add the T to anywhere. You know, like, so if you actually just eliminate things you can't do, you're only left with a few things that you can. And you might actually find if you force yourself to try it, that you just do legal things. So in fact, T is being multiplied. So I'm going to divide by T because I'm eventually trying to get to VF, which is stuck inside parentheses. So I'm going to divide by T, and I get that D over T is equal to VI plus VF over 2. Shout out to my physics fans, because this is a physics equation. When the acceleration is constant, this formula is true. Multiply by 2, I get 2D over T. And you don't have to write it in any specific format, but this is the format that I'm writing it. You could leave it as 2 times D over T equals, well, VI plus VF, F. Then my goal is to solve for F again. So I'm going to subtract VI. And I get that 2D over T minus VI is equal to VF. And the answer is accepted in a lot of different formats. All the answers have to be equivalent to each other, sure, but it's accepted in a lot of different formats. A lot of students would get it in a lot of different ways, like lots of different ways of doing it. Let me just super duper fast do what I was just talking about. So you see, if they distribute the T and they get TD equals TVI plus TVF over 2 times 2, and I'm doing this quicker than the other one because I've already done it once. 2D equals TVI plus TVF. Subtract TVI, subtract TVI. Okay? You got 2D minus TVI equals TVF. Divide by T, and you get that 2D minus TVI over T equals VF. And it looks slightly different from the original answer, but it's actually equivalent. So they accept it. You know? Whatever you know how to do, do it. Do it. All right. Number 29, numero 29. Solve x squared minus 9x equals 36 algebraically for all values of x. So you could do this one by completing the square. You know, let b equal negative, a is equal to 1 already. We've already canceled t. Well, let me start it. B equals negative 9. B over 2 equals negative 9 over 2. B over 2 squared equals 81 over 4 according to my calculator. So you got x squared minus 9x equals 36 plus 81 over 4 plus 81 over 4. And you get that x squared minus 9x plus 81 over 4 equals, and then go to my calculator, 36 plus 81 over 4. 36 plus 81 over 4 equals 56.25. 56.25. And then the left side is a perfect square. So we factor using b over 2. X minus 9 over 2 squared equals 56.25. Now we could actually take the square root of both sides. And we get that x minus 9 over 2 is equal to plus or minus. That's where students get tripped up here. They get one answer. Now, again, the square root of 56.25 actually is a nice number. Square root of 56.25 is 7.5. So plus 9 over 2, plus 9 over 2. You got x is equal to 9 over 2 plus or minus 7.5. So 9 over 2 plus 7.5. And you get 12. And 9 over 2 minus 7.5. You get negative 3. So 12 or negative 3. And just to have one quadratic formula here, let's just do the quadratic formula. X squared minus 9x equals 36. You have to have it in ax squared plus bx plus c equals 0. You have to have ax squared plus bx plus c equals 0 for the quadratic formula. Oops, and I'm blocking that off. A little bit too high. There we go. You have to have ax squared plus bx plus c equals 0 for the quadratic formula to be true. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All over 2a. So I have to subtract 36. Subtract 36. You got x squared minus 9x minus 36 equals 0. So you got that a is equal to 1. B is equal to negative 9, and then C equals negative 36, and you plug into the quadratic formula. So X equals negative parentheses negative 9, negative B, and B is negative 9, plus or minus the square root, and this is another place where students get messed up, negative 9 squared, the negative 9 has to be in parentheses, minus 4, A is 1, C is negative 36, over 2A, 2 times 1. And now we do the arithmetic. We could do the arithmetic on the calculator, but I promised you I would do it on paper. 9 plus or minus radical 81 minus a negative 4 times negative 36 is 144 all over 2. So equals 9 plus or minus radical 225 over 2, which is equal to 9 plus or minus radical 225, according to my calculator, is 15 over 2, which is equal to 9 plus 15 over 2, or 9 minus 15 over 2. And 9 plus 15 is 24, which is divided by 2 is 12. Or 9 minus 15 is negative 6. Negative 6 divided by 2 is negative 3. Same answers. Okay? Bonus, you got a quadratic formula and you got completing the square all in one problem. You are welcome. There's a picture on the bottom right that you can click on if you want to say thank you. Numero 30, number 30. Determine, what time is it? 4:07. I think I'm going to finish this test before I got to go to the party. Determine the shout outs to Lenore. She can't see this because by the time it's out, it's going to be after her retirement party. So congratulations, shout outs to Lenore, and congratulations on your retirement. She's my side eye partner. Love her very much. She's just phenomenal person. Number 30, numero 30, determine the common difference of the arithmetic sequence in which A1 is equal to 5 and A5 is equal to 17, and determine the 21st term of the sequence. So I want to go back to the formula sheet. Again, the formula sheet has things about the arithmetic sequence. So I'm gonna just quick screenshot this. But you do want to go back to the end page for the formula sheet. You don't have to copy and paste the formula sheet, obviously, because, well, you can't, right? But you could write it. So now you know an arithmetic sequence. Even if you don't remember the exact details, and if you don't remember the exact details, it's kind of tough. But the common difference of a sequence in which A1 is equal to 5 and A5 is equal to 17. So you have 5, comma, blank, comma, blank, comma, blank, and then the fifth number is 17. So the question is, what do you have to add to this sequence to get the next number? So you can actually calculate it by process of elimination, luckily. That's pretty rare, but it's a blessing here, right? So if you do 5, 7, 9, 11, 13, you don't get there. 5, 8, 11, 14, 17. Actually, yeah, 8, 11, 14. That's not how I did it on paper. I'll tell you how I did it on paper. And 17, now you got plus 3, plus 3, plus 3, plus 3. And so that the common difference is equal to 3. How did I do it on paper? I did 17 minus 5 over 5 minus 1. This is y2 minus y1 over x2 minus x1. It's the slope formula, which is equal to 12 over 4, which is equal to 3. Okay. Now, just a quick word on common difference. Why is it called a common difference if I'm adding the number? Well, common difference means it's in common. So what's in common? It means that if you take the difference of two successive numbers, you get the same result. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. And then the next one, the difference is also going to be 3. It's going to stay 3 because it's a common difference. Now, determine the 21st term of the sequence. This is one where you could just list them. Be careful and list them one at a time, over and over and over. In fact, you could even be cheapo and say, well, if the fifth one is 17, I added 12. You could get the 9th, the 13th, the 17th, and the 21st. As crazy as it is, you can actually get the second part of this without getting part 1. A1 is equal to 5. A5 is equal to 17. A4 further, 9 is equal to 29, right? It's not common that you could get that. It's a little cheaper way of doing it, but that's just a little hint. A17, A21, you could get it that way. But I'm going to use the arithmetic sequence formula. A sub 21, so this means the 21st term means n is 21. So A sub 21 is equal to A1 plus 21 minus 1 times D. So that's equal to 5 plus 20 times 3, which is equal to 5 plus 60, which is equal to 65. Two different ways of doing this problem. And as a gift, you actually if you just try it, you could actually get the 21st term without getting the common difference if you happen to know that it hops forward by a fixed amount. Blessings upon blessings, right? Numero 31, number 31. Factor 18x squared minus 2 completely. Turned out you can get partial credit if you get this partially right. You can get partial credit here. And I noticed that 18x squared minus 2 have a common factor of 2. So if I start off by factoring out that 2, I get 9x squared minus 1. And I'm already on the right track. We're partway there for a partial credit. Okay, now this is 9x squared minus 1. You could use the quadratic formula to solve for x, to set this equal to 0, and then use the roots to factor this. There's a lot of different options. You could use, the AC method, or you could use a difference of two squares, dots. Difference of two squares. Remember that a squared minus b squared is equal to a plus b, a minus b. I'm going to have to move this over a little bit. Okay. A squared minus b squared is a plus b, a minus b. And 9x squared is a perfect square, and 1 is also a perfect square. You got 2 parentheses 3x squared. 3x times 3x is 9x squared minus 1 squared. That's a difference of squares. Is equal to 2 parentheses a plus b, a minus b. 3x plus 1, 3x minus 1. That's how I do it. And again, you could do it in a lot of other ways. You can get the roots. If you plug into the calculator or graph it, you could get that the roots are plus or minus 1/3, and then use the roots to factor it. Okay? Very, very doable. And very doable for partial credit too. Now solve x squared plus 3x minus 9 equals 0 algebraically for all values of x. Round your answers to the nearest hundredth. Okay, so I want to point this out here. Round your answers to the nearest hundredth. You don't know how many students do this 100% correctly. Use the quadratic formula, get the answer from the quadratic formula, and just stop. Nearest hundredth. Or it says round your answers to the nearest hundredth, and they decide to leave all the decimal points. Or it says to the nearest hundredth, and they do to the nearest tenth, or the nearest thousandth. Nearest hundredth. Do what they said. Round your answer to the nearest hundredth. This is already in ax squared plus bx plus c form, so I'm actually just going to stick to the quadratic formula. They allow the quadratic formula. I actually did this on paper using completing the square, but they allow the quadratic formula, and I see that b is equal to a fraction. It's equal to an odd number, and if you skip completing the square, you skip some fractions. But again, it's a perfectly valid way of doing it, and it works every time. So you could do the completing the square. But a is equal to 1, b equals 3, c equals -9, right? You have to have ax squared plus bx plus c equals 0, which is what we have. And you get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. It's on the sheet. And it actually, so you could remember, you don't have to memorize it. You could actually go to the quadratic formula at the back of the sheet, and it matches the Pop Goes the Weasel tune. So if you don't remember it, you could remember the Pop Goes the Weasel. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And you memorize it. It works every time. It's really easy to remember songs. Plug in the numbers. X equals -3. Doesn't even make it tough with a b negative. So plus or minus the square root of 3 squared minus 4 times a is 1. Oops, a is 1 times c is -9 all over 2 times 1. And you get, now again, the calculator, you could plug it into the calculator now if you want. So -3 plus or minus the square root of 9 minus -36 over 2. And you could plug it into the calculator now too, if this is getting weird. Like, you could plug it into the calculator at this point. So if you get scared of this, but you could plug it into the calculator, just do it. Okay? -3 plus or minus the square root of 45 over 2. Now, I have no desire to simplify this radical because I don't have to. So -3 plus radical 45 over 2, or -3 minus radical 45 over 2. And you get a whole bunch of decimals. And now you do have to remember, like, this is a commonly incorrect gotten problem. Like, a lot of students are like, I don't use parentheses for fractions. Like, teachers told you to do it for the numerator, and then you just kind of didn't. -3 plus square root of 45 out of the radical, close the parentheses, divided by 2, and you get 1.85. And just to show you that if you didn't use the parentheses, you get it wrong. -3 plus radical 45. A less common error is not getting out of the radical before the putting over the over 2. But if you did this without parentheses, you just get the wrong answer. 0.354 is not correct. So you need the parentheses for the numerator. And then the second one with the minus, -4.85. 4.85. Okay? Full credit. And you could have literally skipped right to here with careful calculator work. And you could have done completing the square. All right. So let's read the instructions for part 3. Answer all 4 questions in this part. So there's going to be 4 questions, right? And 4 points means that there's a lot of partial credit. So just because it's harder, don't escape it because it's 4 points. That means that there's also a lot more partial credit. Each part is like a part 2 problem. Okay. Each correct answer will receive 4 credits. Clearly indicate all necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. You know what I said about drawn to scale. For all questions in this part, a correct numerical answer with no work shown receives only 1 credit. So if you get the answer with no work shown, you get a credit. That's a negative, but not really. It's a plus. They don't have to give you credit if you just give the answer. And at 1 point is half a multiple choice question. So do it. All answers should be written in pen except for graphs and drawings, which should be done in pencil. Make sure to stay till the end of the video because I have a little extra thing to say at the end. Número 33, number 33, the senior class at Hills High School is purchasing sports drinks and bottled waters to sell at the school field day. At the local discount store, a case of sports drinks costs $15.79. Sports drinks are more expensive, and a case of bottled water costs $5.69. The senior class has $125 to spend on the drinks. If X represents the number of cases of sports drinks and Y represents the number of cases of bottled water, write an inequality that models the situation. And the second part, I'm going to read the second part, but I'm going to go back and probably reread the first part. It's normal to read the problem more than once. And these parts, 5 times is normal. 9 cases of bottled water to purchase for the year's field trip in the second part. And use your inequality to determine algebraically the maximum number of full cases of sports drinks that can be purchased. Explain your answer. The word explain, you have to use words. Are required, okay? Words are required, okay? So now going back to the first one, X represents the number of cases of sports drinks, and Y represents the number of cases of bottled water. Write an inequality that models the situation. This is where I always, again, love to tell students, I like to write a word inequality before I write the algebraic inequality. Now, about this, I don't know how long this video is going to be in the end, but I know that my Regents algebra, my Regents math videos tend to be right around 3 hours. They tend to be around 3.5 hours. But the thing is that if I have enough time to do an explanation, to do an explanation, to give you advice, to give you hints, to do process of elimination, to do my algebra, to change my hats, and still I could do the whole thing in about the same amount of time that it takes you to do the Regents, then it's probably smart to think that if you do all the same writing that I do, that you actually still have enough time to do all of that, and you'll get all the points with enough time. And so it actually boosts your grade to do all the work that I tell you to do. Again, people, I do work for more discerning clients. I don't force those more discerning clients to do work that's not necessary because they wouldn't rehire me, nor would they refer me to anybody. So I tell them, do as much work as needed to get the right answer. And don't assume that you could just start cutting off work. Don't. Do more than you need if it helps you gain that advice. And here's one example. I write an inequality in words. So it says X represents the number of cases of sports drinks, and I got a bunch of numbers. Sports drinks cost $15.79 case per case. The bottled waters cost $5.69 per case, and they have $125 to spend. So now if I write a verbal inequality without the numbers to model the situation, I know that the cost of the sports drinks plus the costs of the bottled water, that has to be less than or equal to the total money available. There's my word inequality. There is my verbal inequality, okay? So I use that, and I know now the cost of the sports drinks. Now let's do a little bit of analysis because I know a lot of kids mess up this. So a case of sports drinks, costs $15.79. One case of sports drinks costs $15.79. So that means one case, $15.79. 2 cases, 2 times $15.79. 3 cases, 3 times $15.79. I don't necessarily care about what that number is. I want to know how to get it. That's what I really care about. 4 cases, 4 times $15.79. 5 cases, 5 times $15.79. Okay, so what if I don't know the number of cases? Well, if the number of cases is X, okay, X times $15.79. So I got the cost of the sports drinks is 15.79 times X. or x times 1579. You can put the x in front if you want, or behind if you want, whatever you want. Plus the cost of the bottled water. Well, the 1 case of bottled water, $5.69. 2 cases of bottled water, 2 times $5.69. 3 cases of water, 3 times $5.69. 4 cases of bottled water, 4 times $5.69. Y cases of bottled water, Y times $5.69. So $5.69Y. Well, that's less than or equal to the total money available. The total money available is $125. Now, 9 cases of bottled water are purchased for the year's field day. Use this inequality to determine algebraically the maximum number of full cases of sports drinks that can be purchased. 9 cases of bottled water. So this is the number of bottled water cases. This is X. No, see, I almost messed up. Luckily, I have my work over here because this is where a lot of students mess up. They're like X equals 9. They said 9 cases of bottled water, but the number of bottled waters is Y. Y cases of bottled water, 9. Use the inequality to determine algebraically the maximum number of sports drinks, the cases that can be purchased. Now, I'm going to make a mental estimate for the number of cases of sports drinks. I know I'm spending 9 for 9 bottled water, 9 cases of bottled water at $5.69 each. 9 times 5 is 45. 9 times 6 is 54. Half the money on sports drinks. Excess has to be around 4, 3, 4, 5, something like that. Can't be farther. Maximum $60 or so. I don't know. Maybe 70. It's not that much money that's left. I mean, you know, so that's my quick estimate. I just did a quick estimate. It might not be exactly right, but the point is it doesn't have to be, because now if I get my answer, then I know if I got it right. So 15.79x plus 569 times 9 is less than or equal to 125. So I subtract. Now I'm going to use my calculator to get 569 times 9, and I get 51.21. So it actually is less than half. So my estimate was a little bit off, but I said 3, 4, or 5. I said around half, right? 21, and I get 15.79x is less than or equal to 73.79. Divide now by this 15.79. Divide by the 15.79, and I get x is less than or equal to 4.67. And this is where a lot of students get points off, because they round up or they just leave it at 4.67, but you can't buy 0.67 cases of water. So you could say here, since the school can't buy a decimal case A can buy 4 cases of sports drinks. Do you have to use words? Yes. It does say explain. Words are required. Explain means words, okay? Justify, you could justify with algebra. Determine and state, you have to do the algebra and then you have to state it, okay? This says explain, you have to use words to explain it. Número 34, number 34. The path of a rocket is modeled by the function h of t is equal to negative 4.9 t squared plus 49 t, where h is the height in meters above the ground and t is the time in seconds after the rocket is launched. Sketch the graph, and on the set of axes below, state the vertex, explain what the vertex means in this situation. Okay, so about graphing. Look, I've seen so many students who know how to do this question get 0 points on the graph. You might be a fan of being as sloppy as you want to be, and maybe your whole class is sloppy as they want to be, so the teacher just has to pick and choose their battles. It doesn't mean that you've won by being as sloppy as you want to be and your teacher has given you credit because they have to do something. No, graphs are now being graded by stranger teachers. So you can't just assume that they're going to grade your tests nicely. You have to graph neatly. You have to graph neatly. It means that points that are on the graph have to be graphed. You can't just do this thing and think that they're going to give you 2 points for that. So what can we do? We could actually go to the calculator, and we could actually make a table of values. Okay, y equals, let's clear that. So negative 4.9. Now there's no t, but remember you use an x squared plus 49x, and we go to the table of values. Okay. Now I'm gonna actually slide this here, since there we go, since we can. So now I have a table of values. So 0, 0, 1, 44.1. So 44.1, here's 40. So 44, here's 45. 44.1 is just below 45. That is good enough as a dot, but notice it's on the line. Okay, notice it's on the line, slightly below 45. The next one, x equals 2, y equals 78.4, 75, 80. 78.4 is halfway between 75 and 80 or so. Then 102.9 for x equals 3. 102.9, here's 100. 102.9 is between 100 and 105 for x equals 4. 117.6, here's 115. 117.6 is almost exactly halfway between 115 and 120. And then x equals 5. 122.5, between 120 and 125. It's exactly between 120 and 125. And then actually the numbers repeat. So 117.6, 102.9, 78.4, sorry, 78.4. What happened there? And then 44.1. Why does this not draw? There we go. And then 0. And now I connect these. Now, another place where students overdo the neatness, straight lines. Let me be clear about this. Straight lines should be drawn with a ruler. Curved lines should strictly not be drawn with a ruler. So a lot of students are trying to be neat, and they draw this with a straight line with a ruler, but this is not drawn with a ruler because it's not a straight line. We are connecting the dots as smoothly as we can. This is still valid. This is still valid. And there is a full credit graph. Full credit graph. You don't even know how many weird graphs I've seen. Let me just show you. So looking at the model response set, like look, this graph looks exactly like mine. I mean, basically 10 points right there. Now this one also perfect graph. Like a little bit jagged, but you're not drawing it with your ruler. So it's a perfect graph. Here, this looks like a perfect graph, except they still made one graphing error. And you're like, where? But if you draw the arrows down here, this is one of the rare cases where using the arrows is wrong, because the thing is that there is no time here before 0. The object was thrown, and then the object lands on the ground. It doesn't keep going through the ground. So these arrows here are a graphing error. And then this one made a graphing error. The point here is just the wrong point. This point is supposed to be one space to the right, and then it's missing the point at x equals 2. So there is a graphing error here. Okay. So that's one graphing error, and there's a second graphing error over here where this point is in the wrong place. So there's 2 graphing errors. Unfortunately, that's 0 points. You see what I'm talking about? Where the neatness counts. This almost looks like a neat enough graph, and it's not. And then this one, you see, this is what I was talking about. Like this student probably knows how to do the problem and just didn't bother. 0 points. Unfortunately, neatness in handwriting does not correspond to neatness in graphs, because, if your letter A looks like a letter U, but your teacher understands that that's a letter A, then they could read it. Done. You get your credit for words. They're not counting spelling in this test, but graphs mean what they mean. So, anyway, so state the vertex of this function. The vertex is right at the peak, 122.5. Okay, And then that's a point right there. And that explains what the vertex means in the context of the situation. So what's the vertex mean? Well, the rocket is going up, right up until x equals 5. T equals 5, it reaches that peak, and then it goes back down. So that vertex means at time t equals 5 seconds, the rocket reaches its maximum height of 122.5 meters. Full credit question right there. Full credit right there. And a lot of you have the skills to do that. So if you're focusing on the part twos and you didn't even bother reading this question, and it turns out you actually just totally can do this, because I know you know how to create basic graphs, table of values, plot them there. You probably could have gotten 4 points here. And if you know that the vertex occurs at t equals negative b, if you didn't know how to do the graph, but if you actually know how to get the vertex at t equals negative b over 2a, which is negative 49 over 2 times negative 4.9, which is equal to 5. And so that h of 5 is equal to 122.5. The vertex is at 5, 122.5. Even if you didn't know how to do the graph or the bottom part or what the vertex means, you might actually be able to know what the vertex means, the truth is. But here's a point. Like, focus on the whole test, and focus obsessively on extra credit. You deserve it. You deserve it. You deserve every point. Grab every point. Don't let them stop you. Number 35, número 35. Software company kept a record of their annual budget for advertising and their profit for each of the last 8 years. These data are shown in the table below. Click on that face and you will get super duper love from me. So I look at the table: annual advertising budget in thousands and profit in millions. Again, software company again. So I see 1013, it goes up, and I see these numbers seem to go up a little bit also. Software company kept a record of their annual budget for advertising and their profit for each of the last 8 years. These data are shown in the table below. Write a linear regression equation for this data. State to the nearest 100th the correlation coefficient, and state what the correlation coefficient indicates. OMG, how many times are they going to ask this question? They're going to ask it in every single test, so 100% of the time. And when the regents changes, they'll keep asking this question. This is their obsession. So I'm going to do this problem, but like, look, get your calculator out and do it with me. Because honestly, like, they're going to ask it every time. Sometimes they ask it as a part 3. Sometimes they ask it as a part 4 for 6 points. Sometimes they ask it as a multiple choice for 2 points. Sometimes they ask it as a multiple choice and a part 4, and that's 8 points, a tenth of almost of the raw points. And if you just know how to click this into the calculator, you can get full credit. You just have to know how to do it. So follow along and get your points. Okay. So press the stat button. You see the very first option is edit. So you're going to edit a list. I'm going to clear this list. Now, this is just as much a did I know how to do the problem, and did I enter it into the calculator correctly? I do hate that about this problem, but it is a valid thing. Like, this is a real life thing. Entering data into a spreadsheet is such a thing in real life. You have to check that you typed in the numbers correctly. It is worth your time to type in all the numbers and then check if you typed them in correctly. So 10, 13, 14. Type them in and then check if you typed them correctly. 16, 19, 24, 28, 24 again, and 28. Okay. So now I'm going to check if I typed it in correctly. Here's my big one. 10, 13, 14, 16, 19, 24, 24, 28. Nice. Now the next one, go to the right. 2.2. And it, again, worth your time. 2.4. All right. 3.2. All right. 4.6. All right. 5.7. All right. 6.9. 7.9, 9.3. I recommend typing it and then checking it if you type it correctly, because if you're checking as you're doing it, which you can do, but don't overwhelm your brain, and that's the problem. If you type and check at the same time, and that's your check, then you have to obsessively do it, and it kind of can exhaust your mind. So here, now we're going to check 2.2, 2.4, 3.2, 4.6, 5.7, 6.9, 7.9, 9.3. If any of those are typed incorrectly, you'll just get the wrong answer, okay? So we did it correctly. So first off, we did, okay, stat, and then we pressed edit, okay? That's what we did. The second step, you have to do this, turn diagnostics on. Okay, turn diagnostics on. So that's the next step. So now, where's diagnostics on? Some calculators are fancy and you could just go into the mode, but since some of you don't have the mode diagnostics on, you see stat diagnostic wizard off or on. And mine's actually off right now, so I'm going to turn it on. But if some of you don't have that, so I'm going to go to the catalog in blue second button, and catalog. This has every function that the calculator has, every single one of them. Okay? So I'm actually going to scroll to diagnostic on. And it doesn't take that long. Just kind of got to do it. Duper 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 derp. Click my face in the bottom right to subscribe. Diagnostic on. And if you appreciate what you're doing, I really appreciate your subscription. All right, diagnostic on, press enter, enter. A lot of students press it once and don't press it twice. Press enter, enter. Well, you'll know in a second if you actually didn't press enter and enter. Okay, so that's 2. Then 3. Let's do the steps. So we could write it here. How do you get the linear regression question? Stat. The stat button again. Next to edit is calculate. And then this linreg ax plus b. Xlist is usually pre-filled for you, X1, L1, and the Y list is pre-listed L2. There is no frequency list for this. Store the regression equation. You can ignore this part, this just tiny bit if you want, just if it confuses you, but I like to store the equation. So I press the vars button, the Y vars, press function, and I usually store it at the last one, okay? But if you just, you can actually ignore that part. You don't need to do that. And then calculate, okay? And you get this beautiful thing. If you don't see an R, you don't have diagnostics on, okay? So again, stat, calc, and then linreg ax plus b. It happens to be in this case that the decimal points are to the 100th, which is actually really rare. So we could actually do this. We could write y equals ax plus b, and we could write a equals 0.41 and b equals negative 2.31. They accept that. But you could also write y equals 0.41x minus 2.31. Okay? And that's the answer that we usually give. Okay? Nice. And how do I know that I turned diagnostics on? Because R and R squared are diagnostic values. Okay? Now, state to the nearest 100th the correlation coefficient. That's R. And a lot of students say this, 0.98619461116, and expect their 1 point. Except that, well, they didn't do it to the nearest 100th. So R is equal to 0.9 to the nearest 100th. Okay? This is my answer. And if you did 0.98619, it's a 1 point question. So if you give that long decimal, 0. If you did to the nearest 100th, that's 1. Okay. Now, state what this correlation coefficient means in the context of the problem. Well, and it happens to be that 0.99 is really close to 1. So there is a strong positive correlation between x and y. If you just said the word strong, that would actually be a point. But that's what it means. Okay. Just so you know, the r could be between -1 to -0.7 to like -0.2 to 0 to 0.2 to like 0.7 to 1 to 1. Okay. So here, strong negative correlation. This is a moderate negative correlation. This is about a weak negative correlation. So close to zero, because you're never going to get exactly 0, but 0.01, -0.01, negative point, even up to -0.1 to +0.1. Close to 0, no correlation. Then you get a weak positive correlation. Then you have a moderate positive correlation. Then here from 0.7 to 0.1, you have a strong positive. Okay. So what does strong and weak correlation mean? A strong correlation means that like if you graph the dots and you graph the lines, you'd find that the line and the dots are really, really, really close to each other. So this is why I like to store stat plot. Let me see if I could do this. Zoom. Zoom. I don't recommend doing what I'm doing right now. I'm just showing you. We'll ignore that blue. This line that's about to appear. See that line? That's the line. And you see the dots that are really close to the line? That's a strong positive correlation. If the correlation was moderate, the points would be a little bit more spread out. If the correlation was weak, the points would be very spread out. And if there was no correlation, you would still technically get an equation, but the points would be so far away from the line that it doesn't really mean anything. Okay? That was a lot. All right, number 36, number 36. So graph the following system of inequalities on the set of axes below. -2y is less than 3x plus 12, and x is greater than or equal to 3. Label the solution set, and Allison thinks that 2, -9 is a solution to the system. Determine if Allison is correct. Justify your answer. So this is one where there's so much partial credit that like if you're skipping this section, you lose out on so much stuff. Now this one, how to graph this. You get, so -2y is less than 3x plus 12. If you divide by 2, so you get a slope, you get y. Now, this is the division by -2, right? I just almost I made a mistake, but I have my solution set. I just forgot to put the -2 there. But since we're dividing by -2, we switch the order of the inequality. So -3 over 2x minus 6. So you have 1, 2, 3, 4, 5, 6. And you got a slope of -3 over 2. So you go down 3 over 2, up 3 over -2, up 3 over -2, up 3 over -2, up 3 over -2, and up 3 over -2. This is a problem where students try to use straight line, solid line in this inequality, but notice that this is a greater than symbol. If it's a greater than symbol, you use a dotted line, okay? So we have to use a dotted line. And also a ruler, with ruler, because this is a straight line, okay? So let's put the ruler there. Let's see if we can get it in the exact right spot. Okay. Of course, if this is on paper, you could get it perfect, but there's our ruler. And now, oh, nice. There you go. I think that's good. Missing a little line over here. So did I have to use a ruler? Absolutely. Okay. Now, this is y is greater than. So how do I know? Do I shade to the left or to the right? A lot of students see that this is a diagonal with a pretty steep slope, and they're thinking to the left or to the right. But actually, that's not even the right way to think about it at all. This is talking about what property y has. Y is greater than negative 3x, or 3 over 2x minus 6. That's about y. Y is above or below the line. So this is y greater than, that's above. So we're actually shading above the line, and that's the way I want you to think about it, okay? So now we shade above the line. Okay, now the second inequality, well, x is greater than or equal to negative 3. That's at x is greater than negative 3 right there, okay? X is negative 3, okay? Now x is greater than or equal to negative 3. This is a solid line. This is where I'm going to use my red. You don't have to choose two different colors. You just have a pencil, right? Because it's a drawing, you could do it with your pencil. There you go. Let's delete this now. Can I remove it? There we go. Let's just move it there. Now x is greater than or equal to negative 3. Now what about x? This is not up or down, but this is a property of x. X is greater than or equal to negative 3. Now which side of that solid line is x greater? Well, to the left, x is lesser, if we remember the conversation before, and to the right, x is greater. So we're shading to the right. So there. And notice that there's a region that's shaded twice. Okay? So now it says, Allison thinks that it says label the solution set S. So now, this is where I'll use my special pen here, just to have a different color, S. That's the part that's shaded twice, okay? If you can't see it that well, you could do a really dark S. But you gotta really be careful, because what if you're shading over a point in question? So, but that's S. It looks like a galaxy. Okay, so now they're saying Allison thinks that's 2, negative 9 is the solution to the system. Determine if Allison is correct. Justify your answer. Justify your answer. Well, let's justify our answer. At 2, negative 9, we're right actually there. That's 2, negative 9. Okay. So is she correct? No. It feels like it's correct because it looks like it's in the solution set. It's definitely in the red region. And then the question is it in the purple region? But it's on the border. And the thing is that the border is a dotted line. And the point is that the unshaded region, which includes the dotted line, not the dark line, the dotted line is not shaded. It's the boundary between the shaded and unshaded region. And the dotted line is not shaded. The solid line is. So 2, 9 is not in the solution set. Because it is on the dotted line. If it were on the solid line and in the purple region, then it would be. So for example, using my highlighter, like this point right here that I'm highlighting is in the purple region, and it's on the border of the red region, but the red border is solid because we have greater than or equal to. So that highlighted point is in the solution set. Okay. All right. And number 37 in 2 pages. And my last hat. Answer the question in this part. The correct answer will receive 6 credits. Clearly indicate all the necessary steps, including appropriate formula, substitutions, diagrams, graphs, charts, etc. Utilize the information provided to determine your answers. Note that the diagrams are not necessarily drawn to scale. Correct numerical approach with no work shown will receive only 1 credit. All answers should be written in pen except for graphs, drawings, which should be done in pencil. Woo! Now, there's no diagrams here. We're going to graph something in the next page, but there's a lot of places where you can get partial credit again. This is such a phenomenal question for partial credit, and I think it's possible for you to get the full credit. Lydia wants to take art classes. So you're imagining you're Lydia taking art classes. She compares the costs at 2 art centers. Center A, okay, I'm going to Center A. Well, they charge a $25 per hour class, okay, moderate price, and a registration fee, which I love, $25. I hate registration fees, unless they're going to me. But $25 per hour. I don't charge registration fees for tutoring, by the way. $25 per hour for an art class and a registration fee of $25. Now, Center B charges $15 per hour. Oh, that's a cheaper price. That's nice. But a registration fee of $75. Higher registration fee, lower hourly fee. Now, I'm already doing things in my head to imagine myself. Would I want to go to one of these 2 classes? Because I'm saying to myself just to get understanding. Well, it might depend which class I want to go to. Am I going to go to the class a lot? Then I actually want the lower hourly fee. Or am I going to go to the class only a little bit? Then I want to maybe have a lower registration fee. So, and then I bet money that they're going to ask me at which point the prices are equal. So we'll see. Lydia plans to take X hours of classes. We don't know what X is. That's how many classes she's going to take. You're going to take X hours of classes. Write an equation that models this situation where A represents the total cost of Center A. So this is where I was talking about before, where I write a word equation before writing a algebraic equation. They want the equation that represents the cost of Center A. So the cost of Center A, which is equal to A. A represents the cost of Center A, right? But that's going to be equal to, well, it's the registration fee plus the hourly fee. Okay, so the cost of Center A is A, and that's equal to the registration fee. The registration fee is 25 plus the hourly fee. Well, 1 hour, 25. 2 hours, I don't care that it's 50. I care that it's 2 times 25. 3 hours, 3 times 25. 4 hours, 4 times 25. 5 hours, 5 times 25. 6 hours, 6 times 25. 7 hours, 7 times 25. So X hours, X times 25. Or 25X. You could write it A equals, I know a lot of students prefer to write it that way. So A equals 25 plus 25X. Or A equals 25X plus 25. Do you have to write it that way? You actually don't. It doesn't say standard form. So we're stopped. So now write an equation that models the situation where B represents the total cost of Center B. So cost of Center B is equal to the registration fee plus the hourly fee. And so it's B is equal to the registration fee, 75, plus, now the hourly fee, 15 hours, 1 hour, 15. 2 hours, 2 times 15. 3 hours, 3 times 15. 4 hours, 4 times 15. X hours, X times 15. Or 15X, whichever you prefer. Okay, that's another 2 points. I think you could do that. I think you can get that credit. So focusing on just the part 2 for part 1's lost points right there. And also this part, if Lydia wants to take 10 hours of classes, use your equations to determine which center will cost less. You don't actually have to use the equations if you don't have them, like if you don't know how to do them. So if you do this part, you get points even if you didn't use your equations. Remember, because the way we grade, it depends on the previous stuff. Same thing, if you actually get the wrong equations, but you use your equations to get this part, you get full credit if you get this part right based on your equations. You can make up equations and do part B, the second part, the third part, the 10-hour classes, and get full credit if you use your equations. So A of 10 is equal to, now it says determine, and it usually says determine and state, so you better state it, okay? You have to state it. 25 plus 25 times 10, and that's equal to 250 plus 25 is 275. Put it in your calculator, might as well. B of 10, well, that's equal to 75 plus 15 times 10. My prediction is that this is going to be cheaper because that's a lot of hours. And according to my calculator, that's 225. So B costs less. Okay. And this is not done because there's another part. And listen, if you've gotten to this point, I'm really proud of you. I'm proud of the effort that you're making. Uh, Anyone who says that you can't do it is wrong. I know you could do it. I believe in you. You just got you're doing your part. You're almost at the end of the test. Any question, remember this, if you still have time before the test, any question that you got wrong, go back and redo those and then rewatch only those questions and keep doing that until you get them all right. That will get you a really high grade on the Regents. But not only that, it actually does it in a way that's long lasting. It feels like that's a cramming method, and it actually is a cramming method, but it's a way of cramming that is long lasting. So I would advise you to do that. Graph your equations for center A and center B on the set of axes below. State the number of hours of classes when the center will cost the same. So first, graph your equations of center A and center B in the graph below. So first off, you do have to label your graph. Okay. So the second thing is, might as well, I'm going to do zoom standard. So, okay. So the first one was 25 plus 25x. And the second one was 75 plus 15x. Then I go to my table. And I got 25. So now I have my table here. And I can use my table to construct the graphs. Okay. And I do have to label them. Okay. And I do have to use a straight edge. So 25, 50, 75, go over 100, 125, 1/3, 150, 175. Remember, we start at 0. So I'm going to start at exactly 0 because there is no negative time in this case. So that we could do. We could go past the top because there is, you could go as arbitrarily far as you want. I'm going to draw that. And this was A. Okay? You do have to label your graph. I'm going to change my color now to red. And now I start at 75. And I'm going to go up by 15. So 75 registration fee. Got 90, 105, 120, 135, 150. And there's the time that they actually meet. Nice. 150, 165, 180. Okay. Now I'm bringing that ruler in. I'm going to start right at that dot and draw straight. Okay. You can go past the top dot, but you can't go past the bottom dot. Okay. And I'm going to graph this as B. Okay. Full credit graph. Notice the neatness. Okay. Full credit graph. If you do that, if you just add the neatness to your usual graphing strategy without skipping the neatness, that's points. I get your points. They're yours. And state the number of hours of classes when the center will cost the same. So I go down from here, 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 up 5. Right. 5 hours. You don't even have to put the word hours. Guys, girls, we're done. We're done. The Regents is done. You did everything that you could. I said, stick around. You did everything that you could. So I'm really proud of you for getting to this point. I think that if you went through the whole video and you did what I said, you did every problem, you tried it first, and then you saw how I did it, and you wrote down everything I did. And during the multiple choice, if you actually selected an answer before you saw me do it, that honestly, you did everything right. Now, if the Regents is in about 5 minutes, good luck. Do what you got to do. Neatness counts, algebra counts. Show all your work. You'll get your answers. If you don't know how to do the problem, use correct math to eliminate incorrect answers. Use correct estimates as opposed to just guessing. Do whatever you need to do to get an answer. And don't focus on just the multiple choice. Focus on the part 2s, 3s, and 4s. But on the multiple choice, do show work. Forget that temptation to not show anything. Your teacher was right. Your teacher said to show your work, and they were right. They're just right. I said it, they're right. I said it 1,000 times. Click on my face because that's extra credit. And if the last thing I did mention, I know a lot of students already clicked on it, clicked away because I'm already done with doing all the problems. But for those of you who haven't clicked away, what is going on with the hats thing? So I said stick around. So, and thank you for sticking around. And I said that I promised that, let me just put this on, put this over here, take this on. There you go. I promised that there would be something relevant with the hats, right? Um, this is what it is. If you go into the description of the video, there is a free, and I mean totally free, SAT/ACT practice assignments there. If you go and sign up for it, it's free, totally free, not fake free, totally free. And you do have to give your email address. I only email with advice. I do include, my business information in that email, and you can unsubscribe. But I never send an email just to advertise. Nor does anyone ever see your email other than me. And so more advice, more free advice, nothing better. But it asks you a question, and it asks you if you watch my video, and it asks you if you subscribe. Based on the video, what is the answer to the question? It's like, what? And so here is what the questions are. Here's what the questions are. First, are you subscribed? The answer does have to be yes, so make sure you're subscribed. The second, what video did you watch in which I asked the question? That would be the name of this video. And then the next question is, how many times I changed my hats. So I see 4 hats up there, and I'm wearing another one. That is the total number of hats, but I'm not tricking you in terms of the number of times I changed my hat. I just changed my hats right in front of you. So if you saw me change my hat, it counts. So you answer those questions, and the of all the people who answer for my January videos, January 2024 videos for the August 2023 Regents, you will be entered into a random drawing to win 3 hours of free tutoring during the summer from me. From me. And you know that I usually cater to more discerning clients. So hopefully my tutoring is something that you would appreciate. If you do that, you win your 3 free hours of tutoring. Then during the summer you get 3 free hours of tutoring, and that's from me to you. I've always wanted to have an arm of my business, be where I have to make money, because of course everyone has to eat. But the other part is I've always wanted to give some of it away for free for people who, or like me, who maybe can't afford prices that more discerning clients may be able to afford. Okay, so yeah, do it. And listen, I'm proud of you for getting to this point. I want to thank you for watching this video. If you click on my face and subscribe, you get extra credit. You'll get everything you deserve, and you'll probably ace the exam, or you'll just be subscribed. And thank you so much for watching this video. Go back, and any problem that you got wrong, redo the problems and then watch the video again and get them right. And if you do, then I'm sure you'll do really well on this test. All right. Congrats, and I will see you in the next video.